Okay. And it looks like we have a good connection. Just waiting for us to pop up here on YouTube. Perfect. All right, so today we have ourselves a MacBook Air 11-inch. This one is in because it's just simply not turning on. I did pop off the bottom and find a little bit of liquid damage on here, and since my last stream, I've actually gotten some software that works with my hardware here. So here I got a multimeter that now plugs in through USB, and here I have my DC power supply. So whenever we hook up a cable to our MacBook here, we pull, I think it's like 0.17. Let's go ahead and switch over to the overhead cam. So when we plug in our MagSafe 2, let's see how much power we consume. Not even that, 0.011. So this is just not even turning on. We're not even getting a light on our MagSafe here. And to have fun with our new multimeter software, let's check and see if we have our PP3V42, because that needs to be present before we even get a light on our MagSafe charger. So PP3V42 on this is going to be over on this side of the MacBook Air, and we are getting 3.45, so that is close enough. So somewhere between 3.4, or our PP3V42, and our SMC, we are not getting a signal on the Sys1 wire to actually turn on our charger. So, out of curiosity, let's go ahead and turn off our power supply, or just simply unplug it. What do we have? Looks like a little bit of corrosion in our SPI connector. Do we have a PPBus being generated? PPBus is present. All right, so at this point, being that I do see a little bit of liquid damage here on our SPI connector, I'm going to go ahead and pull out the board. I think we need to address that first. And just to show you underneath the microscope camera, when we zoom in, let's get all of this calibrated for the evening. All right, so it's good on my end. Let's try to get it focused now on the camera. So we got a great bit of corrosion, and what I'm really concerned is that pin on the far left. So let's check and see real quick on our schematics what exactly that part of the SPI connector is. So let's go ahead and open up our FlexBoard View software. If you need to get FlexBoard View, you can check it out at Paul Daniels' website, which is pldaniels.com. And it's been a while since we've worked on an 820-3435, so I'm actually going to have to pull it up. 820-3435. And let's see what we got here. So our JTAG connection, which goes to the SPI, is J6100. And we got SMC TMS is touching ground. We're just going to go ahead and pull this connector off and see what happens, but I want to pull this out of the board first, out of the housing first, before we do anything else. So let's switch over to our overhead cam and just work on pulling our board out. I'm actually going to have to put my glasses on for this one. It's been a little minute since I've worked on an 11-inch MacBook. We really don't see too many of these anymore since Apple discontinued them in 2015. This one being a 820-3435 is going to be either a 2013 or 2014 model. They use the same board number for both of those years. But what I like about this specific board is that it pretty much shares the same parts as an 820-3437, which is the 13-inch that came out the exact same year. So you can just use a donor board from a 13-inch of the same year for this specific repair. And I'm very happy I have the software up here working now, but I do want to get Paul Daniels' software. The multimeter I'm using, it's actually one that he recommended on his website that works strictly with multimeter software. But what I'm having problems with is I don't know how to compile his code. You would think I would, since I did take about 2 semesters of computer programming, but we only learned C++ in basic as far as what his code is in. Actually, I have no idea how to render it or compile it. So if anyone has access or knows how to compile Paul Daniel's code for his multimeter software, please let me know. If not, I may have to reach out to him on the Rossman Discord. The main thing is he's in Australia, so I don't want to disturb him while he's sleeping. And then while he's doing live streams, I'm sleeping. Aha! We got a great bit of liquid damage on the back of our board. So we have more than just liquid damage on our SPI connector. So let's set this board aside. Actually, let me pull out the MagSafe board, just so that as we continue to work on this, we can hook this up to our charger and see if we get any changes in amperage consumption. You'll have to pardon me for a moment. I'm going to just mute the microphone. 1, 2, 3. Okay, and we're back. Sorry about that. Had a very important family emergency phone call. Back to the repair though. Looks like we have a couple of dropped frames here. What is going on? Okay. We'll have to take care of that. So there is some liquid on the bottom of the board, some liquid damage that is now oxidized. So whenever we flip it over, oh, that was weird. We have a good bit of corrosion over here. So let's find out exactly what this is. So let's pull up our flex board view. And Malwarebytes, thank you, but we don't need an update at this time. Let's flip over, and it looks like it is just a little bit over our SPI. Here it is. So U1950, which from my experience has been a logic gate. Let's see if that's what it is. Yep. All right, so what this is, and I actually just edited a video that I did last year talking about this exact same thing. This is a logic gate that is responsible for turning or sending a signal to our platform controller hub that it is getting the proper power to turn on. Now, I actually have still not been able to understand the circuit, because what is so confusing about it is that what the logic gate does is it takes PP3V4 to G3 hot, and in order for it to go from pin 8 to pin 7 to make PMSOP good, both pin 1 and pin 2 have to be present. So pin 1 is all sys power good. So all the power needs to be present, as well as CPU VRP good present before it will send the signal. But, correct me if I'm wrong, I believe that all sys power good will not be present until we actually have a signal from our PMPCHP power OK to turn on our PM sleep S4L line, to turn on the rest of our power rails. So like PP5VS5, PP3V3S5, S4, S3, and eventually it makes all sys power good. So this line cannot be present until this line is present, but this line will not be present until this line is present. So still confused about it, but there is a lot of damage around it. We're just going to go ahead and replace U1950 to see if that changes anything in our amperage consumption. Switch back over to our microscope camera. Let's go ahead and turn on our fume extractor. And just kind of clean it up a little bit. Whatever this little square is right there, we're probably going to end up replacing that as well. Actually, looking at it, now that we just kind of touched it up, it doesn't look that bad. But just not to get trolled from the last time, we're going to go ahead and pull it off anyways. It looks like it is set up on a latching on configuration. Is that referring to the logic gate on U1950? And now that I'm actually looking at it, U1950 looks okay, but there was a great deal of damage around it, so I'm going to still end up pulling it off. Is set up in a latching on configuration. I'm going to have to look into that because I'm not quite too sure what that means. Do I see glitter at the top left? Yes, you did see glitter there for a second. It probably fell in through the keyboard. I did have a 12-inch MacBook come in here not long ago where someone was doing their nails over, and they spilt a whole bottle of acetone onto the keyboard. And needless to say, the keyboard was not moving anymore since it had been completely melted away. Okay, now we gotta find a donor board. Alright, so we got a donor board right here. And this board here is actually a 13-inch MacBook Air, but it uses the same components. Just about all the same components. So I know that this U1950 will work. Also, I've had a couple of comments recently saying that my Microscope camera during the live streams looks very blurry or grainy. This is a $80 Microscope camera that I got off of eBay probably about a year and a half ago. But I am open to suggestions on replacement cameras, because this one has done the job, but if it's not really doing that well performance during a live stream, I'm not opposed to getting a different one. Alright, I have actually lost my place where we pulled this from. Let me reference my my schematic here. Oh yeah, that's right, just a little bit above our SPI. Aha. Just gonna turn this sideways. And let's heat the area up. Sorry, my hands are a little shaky right now. Just to kind of get the rest of the evening going, I did have 2 cups of coffee. Today was a strange day. We had 8 iPads dropped off in one day, which is a little unusual for us. Alright, let's see. Are you going to blow away if I kind of let go of you with tweezers? Let's put a little bit more flux on here to help melt some of the solder. If anything, it's a little overexposed. I did increase my exposure, so I can change that. What I think will help out is getting a brighter LED ring to go around my lens. Alright, it's starting to dance into place. Now this pin up here is taking a little bit longer to melt. But once that melts right here, then this is in place. Perfect. While it's cooling off, let's kind of examine the rest of the board. So we got a lot of junk around here too. And while this is cooling off, let's see what exactly that can be. So that's going to be our U8180. Which looks like is responsible for PM Sleep S3 buff L, which eventually turns on our SOs. So that is something that we may have to address later. We weren't getting a light, so we still have to see what is going on with our Sys1 wire. And then that capacitor just looks hella oxidized. Oh, sorry. Forgot to switch over to my microscope camera. Yeah, so this looks really, really oxidized. And let's see, that goes to PP5ES5. And the really, really gross one right here is going to be part of memory. While this is cooling down, let's just check and see if there's an obvious short right here. Nope. Awesome. Okay. Now that we cleaned up that area real quick, let's check and see if we get a different reading on our amperage consumption. Wow, there definitely is some dropped frames here. I need to get my other streaming rig working. This computer is my old school Core 2 Duo computer, and it gets the job done, but it's definitely not the quality that I'd like it to be. I've mentioned in my last streams, what happened to my other computer was I think either my CPU is dying or my power supply, which is a fairly new power supply, is not sending all the power that it needs. So the CPU might be underclocking itself because it is performing at a fifth of what it normally is. So it's, believe it or not, this computer is actually better to stream with than my other streaming rig. I just haven't had any free time here in the store to actually bring my personal, or try to fix my personal computer. Okay. Copaz has appeared. Hey! Alright, let's see what happens when we have it connected. We're now getting a fan spin and amperage the proper amperage consumption, but we're still missing a light here. Now, could it be that this is just a defective MagSafe? And see, you can let's see, where is it? Right here. You can see we're now consuming 0.3. It spiked up there to 0.7, which is usually booting amperage, and we do have our fan spin. So I'm curious if we have an SO line here too. What's this? Question, is R1465 no stuff on board? Says so in schematic, but haven't seen WF. Just kidding. Oh, and just like that, we actually now have... Well, that wasn't supposed to happen. Hold on, let's see what's going on here. I'll check out R1465 here in a second. Interesting. Yeah, we're now getting a light. So I think we might have something that's partially working. Real quick, let me check and see if we have our SO lines, and then after that I will check R1465. So let's take a look back at that MOSFET that looked pretty gross. Okay, so it was U8180, which eventually makes its way to these different enable signals. I'm not really too concerned about the enable signal. I actually just want to see if we have our power rail. So see if like PP5ESO is present, PP3V3SO, and CPU V-core. Let's see, this is memory, I think. Yeah, because it's talking about our RAM right here with DDR. We'll just search the old-fashioned way. So PP5V underscore SO. Let's see in the general area that we are. Now we can just look right here at C80. 8005. Switch our multimeter to voltage. And it's going to be that tiny little component over here on the right side. Do we have SO? We should, since we have fan spin. We do. All right, I'm just going to jump straight into CPU vCore, see if that's present. Over here on the power aliases, I always forget what it's called, so it's PPVCC SO CPU. We have some lines here on the back of it. It's going to be all these tiny little capacitors. And we should be getting about 1.8 volts. Those capacitors that actually aren't there, they're just test points, or solder points. 1.8. Perfect. All right, so it looks like that this one may be fixed. We'll have to do a couple of tests on it, hook it back up, but let's check and see what R1960 is, because I actually haven't read that part of the schematic yet. So R1960 is also part of our PCH Power OK generation. It says no stuff, and it was directly next to U1950, which is where we were working at. But it looks like it's there. But the one underneath it is not there, which would be R1963? Nope. R1963 is present, so it was just the way how the software looked. R1960 is no stuff, so that it does seem to be missing. So awesome. This looks like this may have been a pretty quick repair. Let's go ahead and put it back into the housing and see if we actually get everything else working. Whack. I want to see if this will actually boot up into the login screen. And then after that, we'll end up removing the this SPI connection. I had a 13-inch 2017 that I wanted to do a live stream on, and it came from Apple. It was liquid damage, and the client said it didn't turn on. But when I was testing out my multimeter software and my power supply software, it turned on no problem. There is corrosion in it, but I'm going to check and see why it wasn't turning on before. But I was wanting to do a live stream on that, but that one was going to be boring. Okay, so we're just going to temporarily float in this connection. It's not going to look pretty. Just enough to see if we get anything on the display. Oh yeah, Tim, I saw your video yesterday about you adding LED lights onto your 3437. That looked really cool. I've heard of it being done, but I've actually never seen it done before. I think that definitely would help out in certain instances when you're trying to figure out if you have a corrupted SPI. Yeah, if anything, it would just be fun to do. Add some lights into the inside of your computer. Alright, so let's connect our IPD cable just so that we have a working trackpad and keyboard. Not really worried about keyboard backlights, we'll leave that out. And we can also leave out the Wi-Fi. And just so we don't see the client data, I'm going to boot into a test drive. Let me go grab a test drive real quick. All right, yeah, now we're getting a light just fine. So what I think happened is when I pulled the board out, I actually didn't have the MagSafe I/O board connected all the way, because it seems to be working every single time now. All right, so this is going to turn on 3 times before it actually boots up all the way. And I see a backlight. There we go. And what kind of test do we have on here? Let's do test High Sierra. That always seems to be a nice, safe one to work with. And now we just have to wait for it to turn on. Okay, now get out an A1465 20 volts and 0 amps and fix. We have a couple of different repairs in right now. I now have a MacBook Air that I think is doing that exact same description, 2017. While I'm waiting for this to boot up, let me check in Repair Shopper to see if that's the case. I don't know why it's not showing an Apple logo. There it goes. Just took a second. And while it's thinking about it, let's see what else we have in queue. Let's see, liquid damage 13-inch MacBook Air. And what is going on with this one? Spilled diet lemonade on the device. Okay. Only pulls 5 volts with pulsing amperage. I can take a quick look at that one. Mostly I wanted to do this live stream just to kind of show off the, or not show off, I guess I should say test to see if this software was actually going to work. I successfully replaced the USB-C connector on an 82001041. Nice. Cool. So this is booting up just fine. So I think we may have fixed our issue. I'm still going to run some more tests on it before we give it an ultrasonic cleaning. Just because the last time I did that, we were actually missing Thunderbolt and didn't have a working display. But it looks like that this one is working. Software is fancy. Thank you. It's actually just the software that comes with the power supply and the multimeter. I definitely want to get whatever Paul Daniels has. Probably have to reach out to him. Cool. So this looks like this is a successful board repair. It turns on. It didn't have power, but it has power now. Lots of peeps on repair forums said it can't be done. Okay. Cool. So that was a successful repair. This one we were just getting absolutely nothing. It was about 0.0011 amps, very, very little. And, well, I guess you could say it'd be 1 milliamp is what it was pulling. And whenever we pulled the logic board out, we found a little bit of liquid damage on our U1950. Now, U1950 is a logic gate which is responsible for sending a signal to our platform controller hub, which is built into our processor, which is going to then generate our other lines like PM Sleep S4L, which is the line needed to kick the computer out of the S5 state, go into S4, S3, and SO. SO meaning turned on all the way. So there was a lot of corrosion, but just kind of took a chance since there was a lot of liquid around U1950 to just straight up replace it. And that seems to have fixed the issue. And like I said, we're going to do some more quality control testing on it, but that seems to be a successful board repair. So awesome. That's going to be the end of this stream, but I'm not going to completely cut it. Let's go ahead and kind of dive into that MacBook Air I was just talking about, because this one is really quick. Let's shut this down and go grab that board. Let's see which bin that one is in. Thanks, Tim. I needed a win lately. I haven't really had time to do board repair during store hours. Just too much administrative stuff lately, and a lot of iPads, lots of phones. We've actually done more phones this month than computers. What bin is that one in? Okay. And I will be right back. Let's reset our area. Do you board repair phones too? I used to. It's mostly for data recovery. I'd say really the only board repair I really offer, and it's mostly because of one of my videos has been sending in a lot of mail-in board repairs, has been iPhone 7 audio IC. If it's anything other than that, we might mess around with a VDD main short, but we're just been so busy with Mac board repairs, I haven't really had as much time to dedicate to iPhone board repairs. I know now with the new M1s, I think you have to know a little bit of iPhone board repair to kind of work on them. I might be wrong about that. I haven't actually worked on an M1 yet. But now we actually had a client who had a shorted Wi-Fi IC on an iPhone 7, and pretty much had just convinced them to maybe get something a little bit newer. This one sounds crunchy. But I'd say we do more data recovery on iPhones for board repairs than anything else, as far as the iPhones go. But we do have a lot of walk-in clients, so we do service just general screen repair, battery replacements, things like that. Especially because the Apple Store across the street has been at max capacity. We've kind of gotten their overflow. All right. Cool. Now I just kind of got to do my intro so that I can download this and edit this in about a year or so, since I can never find time to actually edit my videos anymore. So. All right, so today we have ourselves a 13-inch MacBook Air. I believe this one is a 2017 or 2018. The model number is a A1465. I believe it's 2017. And this one is in here because Diet Lemonade was spilled onto the keyboard. It's no longer turning on. Whenever we hook it up to our USB ammeter, we're only pulling 5 volts at 0 amps, pulsing amperage. So that usually means that the charging circuit or our PP3V3G3 hot could potentially be missing, or just our CD3215 chips, which are responsible for turning on 20 volts, which creates PPBus and turns on the rest of the computer, could be missing. So let me go ahead and grab my USB-C ammeter and just confirm the voltage on this. A1465 run. Alright, for now I guess we can go ahead and turn off this multimeter software, because we really won't need it since this doesn't plug in through our DC power supply. Yes, please turn off. So the multimeter software is just going to be kind of hanging out right here. Alright, so let's flip over to our overhead, not our microscope, but our camera, and check and see what we get when we plug in our USB-C ammeter. We are getting 5 volts, 0.4 amps, 0.1. So it almost looks like it spiked and then it dropped. So it could potentially be something with current sensing. and it's just kind of hanging out at 0.1, not really going anywhere else than that. So let's find out exactly why this MacBook is not getting 20 volts and turning on. This is all out of focus. It doesn't like the sheen. Yeah, this camera really doesn't like this computer. Check the other port. You say the other port, but I actually forgot which port I tested, so let me test them both again, Tim. Oh, you may be onto something. We got 20 volts and 0 amps on this port. So, this CD3215 is turning on, but we are getting 0 amps, just as you had asked in the last repair. Go back to the other port. We're now getting 20 volts and 0 amps. What just happened here? Why were we getting 5 volts a second ago, and our notation said when it came in we were getting 5 volts? Bad CD3215 is what Tim says. Let's just open up this computer since it still has the bottom plates on, bottom screws on, and see what happens. I need a screw tray, but it looks like we've been so busy we are utilizing the majority of them. On top of that, where is my screwdriver set? Aha, here it is. All right. But yeah, I haven't really been able to do board repair as much during the store hours. The main problem I have is I love my clients. They love talking to me. And it's bad to the point they actually don't want to talk to any of my other technicians here. They want to talk to me, and it's usually something friendly, or they want to buy us lunch here since there's a Chick-fil-A in the parking lot, which is really, really nice. But the downside, though, is when I'm not talking, I'm not getting repairs done, and I could talk forever, so it's kind of hard for me to step away from a conversation to get back to work. So I tend to do board repairs at 11 o'clock on a Wednesday, like tonight, just so that I can actually get work done. Phone calls aren't going off, emails aren't coming through, customers aren't staring at me while I do board repairs. 20 volts now, yes, that's what's strange, but we got 20 volts at 0 amp consumption. Alright, so the first thing we'll want to do is just go ahead and unplug the battery. Now, while there was diet lemonade spilled into this computer, a technician had actually already taken this apart and tried to dry up as much as they could just to prevent oxidation. So this has been opened, it was just put back together while we were waiting for approval from the client. This one still has the fan in it. This has the fan technology. Not like the new fanless technology ones. It's just a little bit louder than the new one. Actually, to make things a little bit easier, just so that we're not switching back and forth as much, let's get 2 different screwdrivers. The wireless fan technology. Yes. You know, one of the funniest stories I've ever had in the repair industry is when I had an internship back in college working at a PC repair shop. My mentor had sold someone a computer. I don't even know what computer it was. It was probably just like a generic Dell Precision. And the customer asked if it was a wireless computer. And it was a laptop, so of course he said yes. Well, the next day the customer came back in and was yelling at him. Now this wasn't really in the best part of town. So the clients were just a little bit already on edge. So when they came into the store, he started yelling and said, "You ripped me off." And he said, "What are you talking about?" He said, you said this was a wireless computer. This computer's not wireless." And he said, "What are you talking about? It has Wi-Fi built into it. Are you having an issue with your network at home? Or are you just having made sure that the Wi-Fi is even turned on?" And he said, "No, it died." And he was confused. He said, "Well, what do you mean?" He said, "Well, it died. It never actually like turned back on. And I had to use a wired charger to turn it on. But you said it was wireless." And he ended up taking the computer back and issuing the guy a refund. But the customer had thought that the computer was 100% wireless, as in it didn't need to charge using a DC power supply. And my mentor had to kind of explain AC and DC technology to the client. So I'm not sure if maybe they just lived in a place where they didn't have proper power. But yeah, it was a network wireless computer, but it wasn't a powered wireless computer. So that story is always kind of stuck to me. That was back in 2014, I heard that, in North Charleston. All right, let me grab a USB-C. Now, admittedly, this USB-C comes from a 13-inch MacBook Pro, but it still works. You can still use this USB-C connector on a MacBook Air, and it works. Now, let's hook it back up and see what we get as far as power goes. 5 volts, 0.2. Now the difference is I am using a different USB-C. As mentioned, this goes to a MacBook Pro, so I might have to hook theirs back in. 5 volts, 0 amps, and fluctuating. Let's see, before I put my my foot in my mouth, if this actually is compatible with a MacBook Air. Let's put this back in their housing and see if we get 20 volts again. That definitely was strange. As we were getting 20 volts for a split second there at 0 amperage. From my experience, usually means there's a shorted power line, like a PPBus, or the last one I did was a shorted PP5ES4 line. So hooking back in using their USB-C, and 5 volts, 0.2 amps. So something's definitely going on with our charging circuit. I can't really explain how we got 20 volts a second ago. Yep, still 5 volts, 0.2 amps. Okay. Just double checking. So the first thing I want to check is to see if we have a PP3v3 G3 hot. And where's the board number on this one? I don't think they actually put the board number on this specific one. Ah, here it is, 82001521A. I'm pretty sure we have this because we've done a couple of these boards, so let's switch over to our Flex Board View software here and see if we've worked on one recently. Yes, actually. One of the very last ones we did. Alright, so what I want to search for is PP3v3 underscore G3 hot. And that's going to be in a lot of different places, but specifically I want to look around our CD3215s. Just making sure that that's focused. Hook up our power and grab our multimeter. So this capacitor right here is supposed to be PP3B3. Do we have PP3B3? We have we have 3.28. That's close, but that makes me a little suspicious that something is partially shorting out our 3.3 volt line, which could also still be a bad CD3215, which is why it may have turned on at 20 volts a second ago, but now we're still getting 5 volts. Pardon me for one moment. I'll be right back. Okay, sorry, that was parched there. Okay, so back to what we were talking about here. I'm just going to do a visual inspection just to see what was potentially damaged on this board. But if I had to guess, since we did have 20 volts a second ago and not anything now, or we're getting 5 volts now, I'm thinking we probably do have a damaged CD3215. So this side of the board, the part immediately underneath the keyboard, looks okay. Actually, this board looks pretty clean. I know that we have some liquid in this area, and someone has actually already peeled this back to look to see if there was anything here around the SSD, and it looks fine. Definitely have some corrosion on this capacitor. And what is this? Is there anything hiding under here that could be controlling our Thunderbolt? Because it looks like that some liquid may have gone in there. That's the only sign I can really see liquid. Oh, that's going to be U2800, which I think is our Thunderbolt controller. Titan Ridge DP. What are you? USB-C high speed 1. Yeah. From what I've seen on MacBooks, that is going to be our Intel, I think it's Intel, our Thunderbolt controller. Yes, it would be Intel, because Intel created Thunderbolt with Apple. So that could potentially be an issue as well. Okay. So I would say in this case, we're going to be having potentially an issue underneath here, which I'd like to see more, but it's kind of all being covered. Or an issue with a CD3215, which both of these look fine. So we could kind of Russian roulette it and replace one of these like a please bro and check and see if that actually resolves an issue with not getting 20 volts. Or we could have a kernel panicking computer in front of me for a video that I was trying to upload. I'm sorry, 1 second. And it looks like with my personal MacBook Pro, I am going to have to be doing a board repair on it as well. It's been randomly kernel panicking lately, and I think the CPU vCore or phase MOSFETs are probably going bad. But that is repair for another time, unfortunately. Okay, back onto the client repair. So, I want to see what's under here. I think that's what we need to approach first. So I'm going to use a little bit of heat in this general area, as well as tweezers to kind of grab, hot tweezers, to kind of grab this heat plate and lift up at the same time. Actually, hold on. Before I just start blinding replacing parts, I can kind of see what's under there, and let me see if it's related to the computer turning on. It's going to be U2890. Looks like maybe there's some stuff on it. What is U2890 for? Thunderbolt ROM. Okay. Okay, so this is going to be a ROM specifically for our Thunderbolt here, Thunderbolt controller, the U2800. Now, does our Thunderbolt controller need to be working entirely in order for our CD3215s to turn on? I feel like, and please correct me if I'm wrong, our CD3215s should still power on before we get U2800 working. So, when I plugged in our power and we got 20 volts, it was on this CD3215. It was 20 volts at 0 amps. So, we'll toss a coin and see if maybe U3100's bad. I'm being so hesitant with this decision here, because I don't want to just blindly replace a chip. Just plugging power back into here just to see. You can't really see anything through there. See what we are getting now. We're getting 5 volts, 0.2, which is what we were getting before. Switch over to our multimeter, and we check and see if we got PB3B3. We have PB3.28. Okay, before I actually replace the CD3215, I want to use my brain here for a second and check and see if all of our LDOs that are needed for turning on our CD3215 is present. Remember, steps to get 20 volts on charger. That's actually what I was just about to look up, Tim. So what I'm going to do now, because I can never remember the steps, is go to logi.wiki. Let me pull that up here on my screen. So I've mentioned this before, but logi.wiki is a fantastic website. I use it on a almost daily basis. Every time I do a board repair, I pretty much reference it. And it is hosted by Chris at Shiny Computers, but a lot of technicians kind of hive mind together to put information here. So what we want to look at right now is CD3215 boot up sequence. And what we want to check and see is step 1 all the way through step 17. So in this instance, we want to check and see if we have our PP20 volt USB-C line present. So what I'm going to do now is just kind of put this here on the left side and check and see. This might not actually be a 1-for-1 line, so we're probably going to see what the equivalent is in our schematic. It looks like actually that is here. Perfect. So F3010, let's check and see if we have 5 volts there. So it looks like it's going to be this fuse right here. I can see what you're talking about. It does look overexposed now, so let me see if I can change that. Let's drop it down a little bit. Okay, let's do just a little bit more. We'll work with that for the time being. Okay, so let's check and see if we have 5 volts on that line. Nope. So step 1 is already not present. Unless I'm plugged into the wrong port. Let's try that first. Okay, let's try that again. There we go, 5 volts. So I just had my charger right here connected into the other Thunderbolt or CD3215. So, okay, 5 volts is present. Switch back over. And now we're going to check to see if PP3B3 UPC XB LDO is present. And that's going to be C3208. And this should have 3.3 volts. 3.28. It's close. I don't know if it's close enough though. Okay. Now let's check and see if our 1.8 volt LDO is present. It looks like these lines match exactly on my board, so fortunately I can just copy and paste. Makes things a lot easier for me here. So let's check CD3206. It's going to be that tiny little capacitor on the bottom right. 1.79. That is close enough. And there could be a variance here in my multimeter. This is a new one. I was using a Fluke, but it doesn't have a USB interface like this one does. Alright, so let's see if we have our PP1V8 UPC XB LDOD. Alright, CD3205. CD3205 is going to be on the far left of this CD3215. And what do we got? 1.79. It's supposed to be 1.8, so that 0.01 difference should be enough for it to work. Okay, now let's check PP1V1 UPC XB BMC. Should be a 1.1 volt line, and that doesn't look to be a line here. Let's check something out. Let's actually check our U3200 and see if we have an equivalent to that BMC line here, because I think this actually came from a MacBook Pro. Yeah, PP1V1 UPC XB LDO BMC. So that's going to be the equivalent of, what was the other one? XPC XB BMC. UPC XB LDO BMC. It's like a game of spot the difference. It looks to be exactly the same. Although this says LDO BMC. Maybe that's what the difference is. Yep, PP1V1 UPC XB LDO BMC. This one just says PP1V1 UPC XB. There is no LDO. So this isn't a 100% match. It even says right here this is from an A1465, which is a 13-inch MacBook Pro. But this is going to be the equivalent of that line. This is supposed to be 1.1 volts. It's going to be this little guy right here, 1.1 volts. Perfect. All right, so all that is present. Let's go back. And now let's check and see if HV gate 1, first of all, if that even exists on this computer. It does not. U3200. Okay, so let's go to our schematic and see what the equivalent of U3200 is on a MacBook Air versus on a MacBook Pro. Find out if there even is a U3200 on this one. I'm sure it's going to be a different part number, but just in case, we'll take a look. Secondary UPC. U32... Oh, I'm sorry, I'm please broing for my own good here that I actually didn't think about it. U3200 is going to be a CD3215. So, according to our power up sequence, it looks like our CD3215 is supposed to create an HV gate 1 on a MacBook Pro. But this is a MacBook Air, so let's see if there's anything similar to that here. Usually it's all here at the very top. In this case, it looks like it should be UPC XB gate instead of HV gate. And that's gate 1. And then UPC XB gate 2. Actually, I haven't been checking chat. 1 second. The ultimate please bro wiki. You're not wrong, Copaz. Or Rupert. Okay. Cool. So let's check our UPC XB gate 1. And that's going to be right next to this Q3200. So let's switch back over to our microscope and see what we have. There's not really a good point for me to access this. Yeah. I'll try to poke it. I just gotta make sure not to touch anything else over here. Alright, hands, don't fail me now. We're getting 10.9 volts. That seems like an odd number. A1465 has 4 ports. You're not wrong. You're absolutely right. Okay, let's see. So yeah, 5 volts later 20. But we're getting 10 coming out of Q3200. What? Hold on. What about UPC XB gate 2? That's the other side of Q3200. Let's see, what do we got here? 7.8. What? Those are not normal readings. 1 second. 10.1. 7.48. Interesting. I'm going to check the other CD3215 to see if we have a very similar reading. So that's going to be on this gate over here. What is that? Well, this one is Q3200. This one is Q3100. And gate 1 is right here, is on the bottom left side of it. Let's see if it matches that weird 10.1 that we have. Yep, 10.1. So we can probably assume this is going to be our 7.48. Well, this one's now 7.84. The numbers are reversed, but 7.2, 7.8. Let's see if it pulses back down to 7.2, 7.8. Something weird is going on here. Now, I don't know if... I don't know a lot of things in life, but it says 5 volts, later 20 volts. So is it possible that during the startup sequence, something is getting hung up here, and it's trying to go to 20 volts, but it's never going past that? Or is it possible that we have other things that need to turn on that are still kind of preventing this from turning to 20? Interesting. Let's kind of keep going on real quick, but that is something that we need to look at, because that's coming from... Well, I guess in order for this to actually turn on, PPDC and G3 hot, which should be your 5 volt line, which is going into our Q3100, which then eventually is 5 volts, which turns into 20 volts, because we have, this is supposed to be a 20 volt line right here. No, it's a 5 volt line, that's right. This is a 5 volt line. We measured that. That's step 1 right here. Okay, let's keep going real quick. Let's check and see what TBA VDDA is. 1 second, actually. I'm just going to check, see what's going on. I've got an A1913 if you need any readings. It is in for a screen replacement, so the LB works. I might take you up on that. Oh. Okay. So, trying to get my windows adjusted here. Okay, so let's keep going through and check our PPDC and G3 hot. Should read 5 volts because that's what our ammeter says here. In fact, actually, I don't even need a microscope for this one. Oh, 12. Huh. Let's see what this reading is. See, I'm going to try to leave that grounded. Let's see what that reading is when we unplug our charger, plug it back in. So we got 5 volts. Hold on, no, it's just draining. I don't actually have to plug this in. Yeah, it just immediately goes to 12 volts. So, do we have something messed up on our PPDC in? That is not a right reading. Fascinating. Which would make a little bit more sense when we actually read the schematic here, because PPDC in should be exactly what we're getting directly from our power here, but it's only reading 5 volts. Something here is messing with us. And both Q3100 and Q3200 share our PPDC and G3 hot. I'm just checking to see some more stuff here. Why would it be that voltage? Do we have any other weird voltages? So let's look and see what TBA VDDA is. That is non-existent on this computer. And that is something that comes from U7000. Let's see what the equivalent of that is. U7000 should be our ISL. Okay, I'm just kind of reading around to see if we have anything on here very similar. TBA, VDDA, but we have right here a VDDA, but I don't see a TBA. Want to be announced VDDA. Because we have PPDC in G3 hot. It comes through here, which eventually makes its way to our U7000. And U7000 is what's responsible for creating our PP3v3 G3 hot. Out of curiosity, just because I'm not familiar with this specific power line, PP charger VDDA, which is going to be around our U7000. Oh no, my stream must got boring because I lost a couple of viewers. Yeah, it's fine. Right now I'm trying to figure out what's going on. Okay, so here's our ISO. And PP charger VDDA is going to be connected to this line right here. And let's see what we get. 5 volts. That seems like a normal power line to me. And this looks like this should be connected through a resistor right here, PP charger VDDP, which is on the other side of U7800. But it looks like, yeah. So it's going to be present because it cuts through this resistor. So there's really no need of checking that. I changed computers, battery died. Wait, what? Changed the computer's battery died. I'm not too sure what that statement means. Let's check around R7020 real quick, which is going to be a shunt resistor for current sensing. And see what we get on both sides. On check side 1 and side 2. Oh wait, that's on the other side of the board. Gotta flip this over real quick. I had to change a different computer to come back to stream. His battery died. Oh, I gotcha. Sorry, I thought you were doing a repair, Joe. So I was confused when you said that you changed computers and the battery died. I thought you like swapped a computer for a repair and you're saying that your battery died. I misunderstood. Okay, so let's see if we are getting a charger that's not going to pop out of the USB-C port. 1 second. Okay, let's try that again. Yeah, we have 5 volts on that side. Wait, we have 5 volts here. Okay, that's good. And let's check and see on the other side. We can poke this little point right here. 5 volts, okay, that's fine. And that's going to be coming from PPDC and G3 hot. 5 volts. What did I measure a second ago that I thought was DC in, but it was actually 12 volts on one side? Hold on, I'm starting to get lost. Let me retrace my steps here for a second. Yeah, PPDC and G3 hot. Is that not the same line that we just measured? What the actual... What? Okay, so on Q3200, we were getting like 12 volts. 12 volts on PPDC and G3 hot. But whenever I just unplugged the computer and plugged it back in, over on the shunt resistor, we're getting 5 volts, which is what we should be getting. What is going on? Going back for another measurement. Five volts. What? What am I getting trolled on right now? How did I have 12 volts a second ago? Okay. Now that we have 5 volts on PPDC and G3 hot, what do we have on UPC XB gate 1? Let's revisit that, because we were getting like 10 volts, which was an odd reading. Very, very odd. Something is partially working here. Okay. Getting 10 again, which means we're going to get that 7.48 on this side. Yep, 7.4. Okay, can't really touch our DCN on this side. But it is over here. Five volts. Okay, we're just going to continue on. Getting trolled. Okay, let's go back to logi.wiki here real fast. Okay, so PPDC and G3 hot is 5 volts. It's weird it was 12 volts a second ago. Let's check and find whatever the equivalent of TBA VDDA is. In fact, I might actually have to pull the schematics open for a U1706, or U17 and A1706 to see what that is and kind of compare it to the CD3215. Let's kind of just go ahead and do that real fast to please bro ourselves. That should be right here. This was one, and 00239. So we're just going to go ahead and pop over to a random CD3215. Let's look at UB300. Actually, we can just type in TBA _ VDDA and see what that is. Okay, so that's going to be the same line that we were checking a second ago. It's just called something different on our MacBook Air. Let's pop open our MacBook Air schematic again. And let's see, that was around our U7000, our ISO. And on this one, it's called PP Charger VDDA. That's what the equivalent is on a MacBook Air. All right, so we have 5 volts there, or at least we did a second ago. I'm going to recheck now that our computer is reading the proper voltage. So let's switch back over to the microscope camera, try to get it in focus because it keeps unfocusing itself. And there's that tiny, tiny little resistor on the bottom left of our U7000, should be about 5 volts. We got 5.1 volts. That's working. All right, I feel like we're moving forward again. And let's go back and check and see what our next one is. That's going to be Power Management Enable P3v3G3 hot. Should be 3.3 volts, 5 volts on many boards. Good to know. and see if that line is actually present. It's not present here. So let's please bro and see what the equivalent is on our A1465 logic board. Where are you located? What do you come out of? Looks like you are a line that is coming out of our ISL. Alright, so let's go back to our MacBook Air schematic and see where that enable line is. Is it going to be the not connected charger line? One second. Enable VR1. Enable VR1 on this one is called not connected charger enable VR1. But if it's NC, not connected, does that mean that it's not actually here on the specific board? That's what it looks like, because when I right click, we get absolutely nothing. So we can just skip that step in the startup process and go straight to PP3v3 G3 hot. Now, we've checked that many times, but once again, I'm getting some very weird readings here, so we're not going to skip any steps and go back and measure that one more time. So that resistor, or that capacitor that I've probed many times that actually has some of the solder popping off is going to be our PP3v3. And we're getting we're getting 3.28 volts. So again, that's low, but I think that's enough for this to actually turn on. Continue onwards. Next step is going to be our PP1v2 G3 SMC VDDC. VDDC. Does that exist? It does not exist on this specific line. So kind of like what we did earlier, let's open up our A1465 schematic, check and see what that comes out of, and compare it onto our MacBook Air. Now that is a line that is connected to, is that connected? Yep, looks like that's going to be around our U5000. U5000 is our SMC. Let's take a look at this. I think the difference is, and I might be wrong here, I'm probably going to bite myself, is I think there's a T2 chip on this one. Let's find out. U5000. U5000 is going to deal, UART usually is some sort of wireless frequency, but let's see what it says. Secure element. So maybe that is our T2 chip. So this step is actually going to be a little bit different than on our A1465. So it looks like this line actually isn't even present. Okay. This is going to bite me in the ass, but I'm going to skip this for now and just kind of check and see if we have 3 volts on our PP3VO G3 hot AV ref SMC. I feel like that's not going to be here either, since we're working on a board that has a T2 chip. Oh, what happened to our board view software here? Let's just do a search, and yeah, that's what I thought. So that's not present. So there's still a couple more things. I really hate skipping steps at this point. SMBus SMC, we don't necessarily have an SMC on this one because the SMC is integrated into the T2 chip. So I guess let's just keep going. This is probably going to mess with me. Let's check and see what our USB XP CC1 is, if that is even existent. Nope, didn't think so, but what is this? USB-C XP CC1. Well, let's check it out. Alright, that's in the same area as our CD3215 giant resistor. It says that this should be its data, 0.8 volts, and let's figure that out. Did you check PPBus? I thought I did. I'll check that here in a second. Let's see. That is this resistor right here. not getting anything on this. And we're getting 12.3 on PPBus, so PPBus looks to be present. I'm just checking that just in case. Okay, so data verify is supposed to be 0.8 volts, and we're not getting anything on there. Now I feel like that's because either it's not turning on or because we actually need an oscilloscope to measure that line. Just in case, since we're not getting anything, I'm just going to make sure that that line, let's see what the resistance of ground on that line is. It's in the mega ohms, so that has nothing to do with it. So I have a feeling that it's just not being initialized, is all. So somewhere in between here and here, we are getting some inconsistencies. I actually just haven't been able to measure because I need to see what the equivalent is on a T2 chip. In fact, let's check and read some more on our CD3215. Thunderbolt ROM is required to get 20 volts. And that's exactly where we have most of our corrosion on, is the Thunderbolt ROM. It is powered by the CD3215 on the opposite side. It will not boot unless it can communicate. It seems with liquid in that area, the trace between the LDO of the CD3215 and the Thunderbolt ROM gets damaged at a test point. Without communication, the Thunderbolt ROM and the 1.1 volt BMC LDO won't come up while other LDOs will be present. I'm pretty sure we did have 1.1 volts. The 1.1 volt BMC LDO is used to drive the logic negotiating USB PD. When that happens, the USB-C is connected to that CD3215. It will not negotiate the 2015 and get stuck on 5 volts and cycling, which sounds very similar to what we have going on here. Except we do have this specific connection. So, continue reading, sorry. CD3215 is one pair work in master-slave fashion. You can't say that nowadays. For example, on 820.00281, U3200 is the master, while U3100 is the slave. That is good to know. The master is connected directly to the Thunderbolt ROM, U2890, while the slave, U3100, reads the Thunderbolt ROM firmware through the master of U3200. So it's kind of daisy-chained here. This CD3215 is daisy-chained to U3200 until it can actually read the Thunderbolt ROM, which is where a lot of our damage or corrosion was at. As a result, the master U3200 is not working properly. The slave U3100 won't work either. Please note the chip designations and net names are specifically for MacBook Pro, which we already knew. Thank you for whoever updated this information. So, with that being said, I'm just going to go ahead and lift up the cowling that we had that is directly over our Thunderbolt ROM and check and see what's going on, because I feel like that may be where our issue's at. So what we're going to have to do here, I don't want to apply too much heat in this general area because I can't see if our Thunderbolt driver or our actual Thunderbolt controller is underfilled. I'm going to use a heat gun and use my hot tweezers, my micro tweezers, at the same time. And I'm going to pull up with our micro tweezers on one end to kind of heat up the EMI shield, the cowling, the heat shield, whichever you like to call it. And just use a medium temperature here around the board. In fact, actually, what we probably could do is preheat the board old-fashioned way by using a heat gun just to get the whole area of the board a little warm. Let's try that out. I've been preheating my boards lately using an iPad heat mat and just turning it up all the way to 90 degrees Celsius. And that actually has helped me with a lot of things. It will come off easy with just surface soldered. Yeah, I do see that. But since it's connected to ground, I know that it uses a little bit more heat than other connections here. And so I just have this just briefly going over the board. I'm not please broing over it. I'm just trying to get it warm. I'm not trying to get anything hot. I'm not trying to melt anything. I'm just basically trying to get everything warmer than the ambient temperature I have here. I think the last time I pulled one of those off, I used some low melt around it. Not a bad idea. I'll probably go around with my micro pencil to add some solder to it. Just to show I'm not heating this up super hot because I can comfortably hold it. Definitely not trying to reflow the board. Just get it nice and warm. Kind of like when you throw a blanket into the dryer to help you fall asleep at night. That's kind of the temperature I'm going for here. Awesome. And let's switch out to our micro pencil here. Sorry for the noise. And let's just add some low melt solder onto our points here. And the purpose for this is to mix the low melt solder with just the normal solder that Apple has here from the factory to help melt the solder as a whole so that this entire shield will come off. I don't know why my left hand is shaking so much right now. Okay, so we got some low melt solder added onto the surface area of this cowling. Now that everything is warm, let's switch over to micro tweezers. And we'll get our rework station. And let's heat up the area. And we need to go around in circular motions to heat up the entire area. Now what I'll do to try to cheat is I'll take my micro tweezers and just kind of touch this area up and use them as normal tweezers and lift up at the same time. And what I really want to be cautious for is we do have our SSD to the left as well as the T2 chip, which are more than likely underfilled chips, so we don't want to overheat the board. Oh, whoops, that got stuck right there in that corner. Alrighty. Pull this off before the board cools down too quickly and this gets stuck. No, no, come on. We don't want to heat up this area that much. Come on. This is an area I don't like to be around. There we go. And let's just kind of touch up that. Beautiful. I think that was the right amount of heat. Goldilocks. Not too much, not too little. Alright, so here is our Thunderbolt ROM, as well as our Thunderbolt itself. So, what I am curious about, since most of the liquid looked like it went on the Thunderbolt ROM, is if the Thunderbolt ROM needs to be replaced, is it paired to the Thunderbolt controller? Because on the last A1405 I did, it wasn't. In fact, actually, it didn't even... I don't think it had a Thunderbolt ROM. Or at least, if it had one, I didn't need to replace it for the Thunderbolt controller. But I know with the Wi-Fi I see, the Wi-Fi ROM, for instance, is paired. So, if that's the case, does this also need to be replaced, as well as the Thunderbolt ROM, if it turns out that that is our issue? Let's try to get this back in focus. Let's let this cool off for a minute before we do anything else to it. So now let's take a look at U2890 and find out, one, is it even being told to turn on? Alright, so it gets power from PP3v3 UPC XP LDO. Now that line was present when we measured around our CD3215, specifically the U3200. So let's check and see if there's still a connection, because it looks like that there may be a via right here that goes underneath the board to this side. Let's find out. So we have all those resistors right there. That should be reading about 3.3 volts. Are we getting 3.3 volts? 3.28, 3.28, 3.28, 3.28. So all of that power is present. 3.28. That is a 1.1, which was that line that LogiWiki mentioned needed to be present in order for this to do the negotiation to start pulling 20 volts. Okay, so it does look like that it is getting all the power necessary. Thunderbolt X SPI clock. That's what that 1.1 line is. Yep, which talks directly to our CD or U3200 right here. Thunderbolt ROM hold L. So if this is low, this is going to hold this from turning on. But it wasn't low. When we measured that, that actually was 3.3 volts, so that's normal. CS, is that going to be current sensing low? And we had 3 volts there. Pin 2 was also 3 volts, which was Thunderbolt SPI machine in or master in slave out. 3 was Thunderbolt ROM. WPL. WP. WordPress. No, I actually have no idea what the WP stands for. Work protocol. But that was getting 3.3 volts as well. So this is getting power, like it should. We have a crystal right next to it. U3000. And that is supposed to generate a 25 megahertz frequency. Let's examine that crystal. To the naked eye, it looks perfectly fine. But in order for us to confirm, we actually are going to have to hook up our oscilloscope here for a quick second, just to see if we are getting a 25 megahertz frequency coming from that crystal. Okay, so pin 1 is going to be here on the right side. And when we click auto on our oscilloscope, it's not giving anything us for frequency. 1 second. Tim says that WP stands for write protection. That makes a lot more sense since it's a ROM. Thank you. Alright, let's try this one more time with our oscilloscope. We'll plug that in, get a reading. It's turning on and off. We're getting... Hold on, it is jumping all over the place. Let me make sure I'm properly grounded. But it looks like it's going to 25 and turning itself off and on. I'm getting a frequency of 60 hertz. That's not 25 megahertz. That is pin 1 on our crystal. Let's check pin 3 and see what we're getting on that side. Because this is the in, so what's going out? And pin 3 is going to be down here. 60 megahertz. Or no, just 60 hertz, not even megahertz. So, we got something going on here that's new. It's just staying at a solid 60 hertz. So one or two things. Either the schematic is wrong, which I has seen before, but 60 hertz is a weird clock speed, or clock frequency I've actually have not seen before. And just to make sure that we actually have the set right, yes, to the right intonation. All this looks right. Yes, so 60 hertz is odd, and the schematic says we're supposed to get 25 megahertz, which is true to be said with other clocks on other MacBooks. For instance, the MacBook Air I was just working on earlier, that A1465 the actual real-time clock I want to say is about around 25 megahertz. But this clock here is 60 hertz. Now, it takes 1,000 hertz to make a, correct me if I'm wrong, a kilohertz, and then it takes 1,000 kilohertz to make a megahertz. So the fact that we're just getting 60 hertz in general tells me that we're really not getting a reading here. So does that mean that our clock is bad, or does that mean 60 hertz is room interference? Okay. Does that mean that our clock is bad, or does that mean that we're not actually getting a good signal coming from our Thunderbolt X-Tall 25 megahertz in and out? Room interference. Room interference as in not properly grounded, or just interference from, let's say, like a radio wave somewhere in the room. No clock at all at the moment. But Joe here is being so kind to assist me since I'm dumb when it comes to clocks. So 60 hertz room interference basically means that we're not getting any signal at all coming from our clock. So at this point we can either replace the clock or try to figure out what actually creates the signal here for our Thunderbolt XTAL 25 megahertz in and out. Let's find out real quick. Looks like potentially coming from our Thunderbolt controller, but it has to go through a capacitor and a resistor before we get to that point. So something's not properly communicating here with our clock. Could it be that U2890 is not properly turning on our Thunderbolt controller? Does it mean that our Thunderbolt controller is actually bad, which is also not sending a signal directly to our Y3000? Let's find out real quick if there's just a simple short here, or if this resistor is not resisting like it should. Joe here says just 120 volts, 60 hertz. Probe acts as an antenna. No stronger signal to pick up. An antenna for just the room interference. Interesting. Thank you. That means a lot. Awesome. So I'm just going to probe ground and see what our resistance is. Make sure that we're disconnected from power. So this line, we are at 300 kiloohms. This line, we are also at 350 kiloohms and climbing. So no obvious short, which means we potentially have an issue here with our Thunderbolt controller or our ROM. Let's find out if we have a donor board that we can try replacing the ROM with first. And I feel like since it's a ROM, it's going to have some firmware coded that is needed to actually turn on the Thunderbolt controller. Let's see, 60 hertz is line noise from AC, your scope plugged into the wall. What Joe said. Awesome, thank you. I don't really do too much with oscilloscopes too often, so that's really good news, or just information to know in general. So I know I have exactly one donor board, and I think it's from the same year. Let me find out. It is the exact same board here. So let's plug this in and then see what happens. I know that this board did work. Main reason we have it is because the screen and the keyboard and the battery and the logic board were all bad on this specific computer, so the client ended up donating it. Alright, so let's go ahead and remove our EMI shield on our donor board here. Kind of like what I did earlier, I'm just going to go ahead and preheat the area. This one is exciting. I've never done a Thunderbolt ROM repair. OBS reconnected. Probably going to have some drop frames here for a second. Yeah, I don't know what happened there. I got an error message saying that OBS disconnected, but it looks like it reconnected itself. Alright, so like what we did earlier, we're going to apply some low melt flux. Not flux, low melt solder. We're going to apply flux, and then we're going to use some low melt solder. So it's noise warning for those wearing headphones. I can't believe it's already 12 o'clock. I'm going to continue working on this, but I do have to answer this phone call, so it's going to be muted for a minute here. Back. 1, 2, 3. Yeah, we're back. Just got wind, no pun intended, that there is tornado warnings. We actually had a tornado land here last year around this time, so it's very possible we might have a tornado tomorrow. I'll try not to think too much about that tonight. Okay. That resistor right there doesn't look too hot. Now I know this board does turn on, so what I'm going to do for the time being is let this cool off. The extra stress is not needed right now. You're not wrong, Tim. So I'm going to let this board cool down just for a quick second, and then I will measure to see. Well, I guess what that clock, if the clock is actually working on this board, because if we're going to have to end up taking this parts, I want to make sure the parts work. Oh, that's you, Sam. Tim, I'm your wife. I'm sorry. I'm sorry. I'm sorry. For those of you watching, sleeping awake is my wife. She's at home right now while I take care of this repair. Okay, so let's get a bench right now. Okay, so this board right here is taking, excuse me, is taking 20 volts and powering up. So let's see what this clock is supposed to say. Should be on, and let's make sure it actually reads 25 megahertz. Let's see, I think I'm not properly grounded still. Let's ground ourselves right here. You might have measured the 1.1 volt line for BMC LDO. Wrong. Oh, wait, measured the wrong 1.1 volt line. Okay. I can check that here in a moment. So with our board that we know is working, that's ground. Of course, that's not going to give us a proper measurement. Let's check and see what megahertz we're actually supposed to get. Strange. The reason I say strange is because this is reading, it's jumping all over the place actually. 5 megahertz, turning off, 5 megahertz. And this board does work. This board actually does turn on. Let me try reading one more time. Okay, our oscilloscope is doing the same thing on this side. It's going to 5 megahertz and kind of jumping all over the place. Let's see if we can zoom in a little bit more. Sorry, I don't have a way to actually show this. Yeah, I must be using something wrong here because it's sitting around 10 megahertz up here on a known good board. So I'm just making sure that I actually have my oscilloscope set properly. I have the intonation of my probes proper. Okay, something's trolling me here, again. And I think in this sense it's my equipment's not properly set up. Cue the intermission music, because this part is boring. Alright, going back to our actual board, making sure I'm grounded. And let's see what I'm reading as far as my clock goes. It's actually reading the exact same thing as our known good board. So I wasn't properly grounded, which is why we were getting room frequency. So our clock is actually fine. I'm glad I went back and tested that one more time. Yep, same thing here. Okay, so let's not mess with the clock, because it actually looks like it's doing what it should do. Okay, all good, dude. I'm putting a KB into A1502 while I watch. Keyboard. Oh, cool. I'm glad it's somewhat entertaining. Alrighty, so let's take a step back here, because the clock now is just starting to troll me. Okay, so this is for an A1465, but there is some very important information on here that talks about the 1.1 V volt BMC LDO. Now, from what we were seeing here is that it looks like on at least a A1706, there is a trace between the LDO of the CD3215 and the Thunderbolt ROM itself that can get damaged. So let's check and see where the 1.1 volt is on the other side of the board if we can, because while we were getting 1.1 volts on this side over here, that doesn't necessarily mean we were getting 1.1 volts on this side over here. So let's just do a search real quick for hold on one second. It literally just slipped my mind because I was thinking about tornadoes. Here we are. It was the PP1V1 UPC XB, it's LDO BMC. So PP1V1 underscore UPC underscore XB LDO. Search. And while we did have 1.1 volts here, I don't see where else it could go. One second. It is a line right here. Okay. But it doesn't actually go to the Thunderbolt ROM, so maybe we did measure something improperly. This is what we're going to do. We are going to go back to our A1706 schematic, just to make sure we're measuring the right thing. PP1V1 UPC XB BMC. PP1V1 UPC XB BMC. And this is on the A1706. And search. And we're not getting anything here. Okay, let's look at U3200 on the A1706 logic board. Is that not the same thing right here? The 1v1 UPC XB LDO BMC. So I think this may be improperly labeled still. Because if so, if this is correct here, without the communication of the Thunderbolt ROM, the 1.1 volt BMC LDO won't come up while the other LDOs will be present. The 1.1 volt BMC LDO is used to drive the logic negotiations of the USB PD. But where, if that is the same thing on this specific computer, oh, whoops, is that negotiating happening? Because I can see right here, our PP1V1 UPC XB LDO, but it, what? Hold on, I'm actually going to pull up the board view of a different board just to kind of compare. Okay, so there's actually a test point on this specific board view. And it looks like it's a test point that goes directly to the speaker amp? Or the VIA? Hold on. Because the Thunderbolt ROM on this specific computer, which we're not working on, is, well, not the Thunderbolt ROM, but the actual Thunderbolt connection is right here, but this is the Thunderbolt ROM that I have done in the past, and I didn't replace the Thunderbolt ROM, I just replaced the Thunderbolt controller. Let's see what Joe has to say. What's going on here? Joe says pin 35. I think I'm wrong and saw wrong when you did it. USB Police Department. Oh, USB PD. That makes sense. I'm not sure where that exact trace is if the logic board's actually going to show us. Okay, my thought process is kind of all over the place, just kind of blaming other things of what our issue could be here, because we had liquid damage on our Thunderbolt ROM. And for a split second, the device turned on at, and started pulling 20 volts. Most of the liquid was around U2890 and our crystal. Now, I thought we weren't getting anything here on the crystal, but I found out that my oscilloscope here wasn't properly grounded. After I grounded it, I actually was getting a measurement or reading properly on the crystal. So the crystal is turning on, which means that the Thunderbolt controller is also turning on. Oh man, okay, what is going on here? Okay. So the liquid damage was on the Thunderbolt ROM. Why did we start pulling 20 volts all of a sudden? Why were we getting red herrings with our gates at 10 volts and 7 volts? I want to revisit that. Let's look at that again. What is going on here with our PPDCN? Why was it at some point reading 12 volts? And why is it that UPC XB gate 1 was reading 10 volts? So PPDC and G3 hot should be a 5-volt line until otherwise told to turn on. PP20 volt or PP20V USB-C XB VBus F should also be 5 volts. There's a fuse in between until it actually is told to turn on and start generating 20 volts. So why did we have 10 volts here? Let's look back at that again. Let's go back to Q3200. We're going to figure this one out. We're going to figure this one out. It's going to be something like a resistor, a 100 kilo ohm resistor is probably actually reading 30 kilo ohms instead. It's going to be something like that. Okay, let's get this back in focus. Okay, so this is Q3200. CD3217, LOL. Well, this one's a CD3215, so this should be the 2017 model. Okay, so what I wanted to check to see is, one, what is our not PPBus, or PC, sorry, it's starting to get late. PPDC and G3 hot. What is that? And there's not really a clear way of accessing it here on this specific board, but we can, or on that specific one, but we can check it here on Q3100, since that is also PPDC and we're getting 5 volts, like we should. Okay. So this line, which is going to be our gate 1, should also be 5 volts until told to turn on. We are getting 10.9 volts. That's not normal. When we look over here, 7.48, and that is on our gate 2. That's not right. Okay. So 5 volts here. And then this is supposed to be about another 5 volts until otherwise told to turn on. Wrong schematic, hold on. Which is on our fuse right here, F3010, should also be 5 volts. Yeah, 5 volts here. So what is causing our gates to have this weird voltage? Let's compare with a known good board just to make sure that they're actually 20 when they turn on, or they're 5 at first. So this is a known good board. Just because I don't have enough hands, what I'm going to try to do is put my ground, or my negative probe into ground. And then let's go ahead and try to connect our USB-C temporarily. Alright, so this is going to be our gate 1. Right now we have a reading of 0 because nothing's plugged in. Plug it in real quick and see what we get. Oh my god, I guess that is a normal reading. Wait, no, there it goes, 25. Okay, so it stayed at 10 for a second, and then eventually boosted up to 25. No, we'll do that again. So 11, the other one was like 10.9, and then, did I slip? I slipped. 25. Okay, so we're still in the boot up sequence then of our CD3215. Now we're going to confirm down here on our gate 2 and see if this is going to read that 7.48 we had on our patient board. 7.4, and then after a second this should jump up to 20. Okay, so that's actually normal. So what I'm assuming here, that's actually normal. So this board, it's a MacBook Air, while the cheat sheet that we're looking at, logi.wiki, is actually going to be for an A1406, which is a MacBook Pro, 2016 to 2017. So it's very possible with the MacBook Pro, what's going on here is that 5 volts is normal for both gate 1 and gate 2. But for a MacBook Air, it looks like 10 volts on gate 1 is normal, 10.9, 11 volts essentially, and 7.8 volts is normal until it actually powers on to 20 volts. So I thought that was a red herring. Thankfully, we actually had a known good board here just to confirm that. So we can't go completely off the numbers off logi.wiki since this is a MacBook Air, not a MacBook Pro. So with that being said, we now know that the computer is still in the boot up sequence. And where we stopped on the boot up sequence, let me see if I can pull that back up, is going to be on the MacBook Pro on an A1465, which is a T1 computer. Come on. We have SMC, System Management Controller. Well, there isn't a System Management Controller on a MacBook Air. I keep saying 2017, 2018. I'm sorry, I just realized in 2017, they were still using A1466, the non-USB-C. So this actually is a 2018. So this is a T2 chip computer, which has the System Management Controller integrated into the T2 chip. I'm still kind of thinking, is it possible that this is in DFU mode? Why did we get 20 volts a second ago? Well, not a second ago. At this part, it was probably about an hour ago now. Why? What is the next step here? What is the equivalent of the startup sequence for a T2 chip? Let's find out if that information exists. So this is the boot up sequence for the CD3215. I wonder what the boot up sequence is going to be for a T2. Aha, look at this. T2 and CD3215. So there's an entire section here on logi.wiki that we were not looking at. I'm pleased rowing so hard right now. Thank you for bearing with me, guys. So let's look into the documentation on here and see what the next step is since we don't have a system management controller. What would be the next step after our gates turn on? This is going to be for the CD3217. I chose the wrong one. CD3215 power on sequence. And it just links us directly to the CD32 or 17. Now, is that because they share? Let's see. This goes to CD32 power on sequence, CD327. What? Oh, no. Weren't supposed to see that stuff. Even up here, nope, it just directly links. So they probably have the same boot up sequence, redirected from CD3215 power on sequence. There's a lot of good information right here. So CD3217 does not have the LDO output test lines for shorts, otherwise the chip is missing power or bad. Often causes a loop at step 10. Okay, so let's check and see what we have going on here. So I'm just checking to see what the equivalent of step 10 is here. And it's if we're going in order, it'd probably be right here. Alright, so PP3v3G3 hot. Hold on. Too many numbers. I'm going to have to compare to see what we've already messed around with. Let's open this up in another tab and go back to where we were. Okay, so with the CD3215 on T1, we got to as far as the gates, the power manage enable, which comes from our U7000. PP3v3 G3 hot. Next step was our PP1v2. Let's go right here. So right after PP3v3 G3 hot, this is where we're at. The next step is going to be PP3v3 main P good. PP3v3 G3 hot is going to be talk to our PCH. You're then going to get a clock. Then we have P5G3S enable. Okay, P good. SSD power management. So by this time I feel like we should have 20 volts. Okay. So let's start checking this out. Let's check and see if PP3V main P good is present. PU to PP3V3 underscore G3 hot. Okay. I'm gonna just kind of tuck this away real quick. That way I can still check chat at the same time. Okay. So what we were looking at, next line. It's going to be your P3v3, what, main? Is that what it said? Yep, main P good. Okay. Which is going to come from our power management. I'm not sure if this one's called a Piccolo on this specific unit, but it's also going to be around U7650. Okay. Like most of these MacBook Airs, I feel like I was... What is that? What is that? Hold on. Wrong board. Wrong board. Okay. I saw some liquid or some corrosion buildup and thought that's what we needed to address, but this is our board. Okay, so U7650 is this guy. This IC right here. And what we want to check and see is if we have a signal for PP3v3 main P good present. And let's see what we have. It is not present. We have a resistance of 120 ohms and climbing, so that's probably okay, just to compare with our known good board. Ah, we're in the mega ohms right here on our known good board. Okay, I like to see some variation. Measure again, and let's see if it's anything different. Oh, L. Now, is it possible that that line was still just partially charged? No, because on the known good board, we have a reading of 1.4 mega ohms. The resistance to ground. So on the same line, And we have OL. And this line is supposed to be our PP3v3 main P good. Okay, let's double check this again. And I need to zoom in some. Oh, zoomed in a little bit too much. Or zoomed out a little bit too much. Because I actually clicked on the file itself. Okay, so let's zoom in. Okay, so we were getting... Did I skip any steps? We were getting PP3v3 G3 hot. Did I check all this stuff in between? Oh, man. Because we were missing our P3v3 main P good. What's weird is when I check the resistance of ground, it's OL, open line. Let's check R7601 again. Hey, what? What? CD3215, it's cracked. I didn't see a crack there, but let's see, I do have something different here when I checked R7601. Getting 3.2 volts there. Nothing here. And that is R7601. Let's take a look at R7601 and see what it is supposed to read. So it's a PP3v3 G3 hotline, and there is a 100 kilo ohm difference. Okay, let's make sure that's actually reading properly. Yeah, okay, so that's right. I'm going to check where else in the schematic this is supposed to go. So that is a line that is supposed to come out of U7650. So I'm going back to my donor board real quick just to kind of measure that specific resistor, because the strange thing I have is that there's no, and that I have an open line whenever I measure ground on that specific P3v3 main P good. Okay, so of course this is a working board, so let's see what we have here. We have 3.2 volts on that side, 3.3 volts on that side. I'm curious if our issue here is going to be because this chip right here, the U7650, is not turning on, or it could be bad. Man, how did we go from Thunderbolt ROM to U7650 power supply? Is it just late in the night? Is it late in the evening? Alright, so this is our patient board. And when we check that specific resistor, the R7601, on this side we have 3.2, while on the other one we had 3.3. And on this side, the P main, we have 0. Let's unhook power. Okay, so when we were measuring to ground, it's weird. And then it just kind of jumps up to OL. So P33 main P good also goes to U7800, which is going to be, on previous computers, our Piccolo, but it's a power management IC. I don't think we had any liquid around that area. Does not look like it. I wonder if U7650 has anything to do with our issue here. Yeah, because on the known good board, we're getting a measurement of 1.5 megohms to ground on that specific line, the P3B3 main P good. Then we come back here. Now you're just messing with me. We're still in the megohms. Okay, so that's fine. Oh man. Do you need a battery hooked up to get any of these voltages? I don't believe so. On this specific model, you should still be able to just connect to a one of the larger wattage of a USB-C. Only reason I say that is because I have a known good board that is giving us the right voltage versus with just the board itself, no battery connected, while our patient board is not giving us the same readings. So maybe there is still something here we're missing. For fun, okay, I haven't gotten one, to be honest. For fun, I don't know if we're really going to make much progress. Let's put it under a thermal camera and see if there's something that's getting warm. Just to see if there's a partial short somewhere. Let's do that. Let's see what happens. It's always now with the T2 computers, I kind of get lost. Okay, so let's pull up our software. And things are going to get a little choppy here because the stream doesn't like to use the thermal imager. I can already see I got some drop frames. Oh, I got some major. The whole computer as a whole is actually not working like it should. Come on. You can do it. Oh, come on, buddy. You can do it. I can't wait to get my other computer back and run again. It could handle the thermal imager, no problem. Wow, this is really bad right now. I think I'm dropping all my frames. And the thermal imager isn't wanting to change windows. Okay, so you'll just kind of have to take my my trust. Take my word when I tell you what's going on here. So I have this under the thermal imager, and what seems to be getting warm here is the T2 chip. I'm waiting for it to load because this computer is struggling. Yeah, the board's getting warm right now, and it's not really a big difference. The ambient temperature of the board is about 30 degrees. I see our T2 chip is getting about 34 degrees Celsius. So I'd say that's not a thing. That's just the T2 chip is trying to turn on, but something is preventing it. Flipping the board over just to check and see if there's anything else that might be getting warm. It doesn't look like this is actually going to be a good tool tonight, just given the strength. Ooh, that's warm. What is that? You can do it. Almost would need a whole nother computer just for measuring the thermals. Alright, so our T2 chip is still about 35, but on the back of it, something was getting to about 36. What is that? Come on, thermal imager, you can do it. Okay, we're just gonna, that's not enough help. So let's stop our thermal imager software. Because really, all it's showing me is that the T2 is warming up. Alright, let's see if that brings back our stream, if we have any drop frames. That's right, I couldn't show you anything because the camera wasn't actually turning on like it should. So basically, well, the only thing that was getting warm here was the T2 chip itself, which leads me to believe it's just trying to turn on, but it's missing either a power rail or a signal. I don't see any liquid damage around the actual T2 chip itself. Actually, switch over. There's a little bit of corrosion right there, which is near our T2 chip, which is a capacitor. I don't think that's going to be anything that would be preventing it, because it's mostly on the capacitor, not on an actual connection itself. What is that? What is that? Think. PPBus, G3 hot, SSD. So that's going to be mostly for SSD because that is connected to U9060. That's not really anything we need right now because that's going to be for turning on our SSD, which we get to that point eventually. We need 20 volts first. Hold on. Yeah. P2V7NAND enable. That would have to be present in order to actually turn on U9060. So I don't think that's anything that we're looking at this moment. Okay, onward. Once again, this is just going to be something simple as like one tiny resistor, or ultimately just a bad CD3215. And that's our power management IC. Nothing looks... Actually, what's on the side of it? Nothing, just a piece of dust. YouTube is not receiving enough video to maintain a stream. It should be fine now. Get this back in focus. Alright, so let's kind of take a step back again. Let's go back to our startup sequence here. Maybe we got a little bit too ahead of ourselves whenever we were checking our, what was it, our P3v3 main. We can check to see if we even have any of this stuff right here. Because we know we have PP3v3 G3 hot, but do we have something as simple as PP1v8 sleeper S2R? We don't know. Let's find out. Okay, so this part is going to be a little on the boring side. Okay. Where is this connected? Alright, so let's check around our CD3215. Oh, whoops, sorry. I didn't have this screen on. So we're going to check our PP1v8. Basically, we're just going to kind of start from the beginning and work our way down, see what's going on here. Only because we're starting to get... I'm starting to get sleepy. And something that should have been easy is definitely taking some time. Okay, so this is supposed to be a 1.8 volt line. That's exactly what we get. That's normal. All right. In fact, let me open up another window here so I can move this over. Okay, so PP1v8, let's check PMU clock, 1v8 awake. Kind of make our way down and know that we have, let's see if PMU VDD main enable is present. So I'm going to kind of start from the beginning, go a little bit halfway through and see if that stuff's present and then work our way backwards if it's not. So PMU VDD main enable, PMU, not PMUS, PMU VDD main. Hold on, I lost my place. VDD main. I don't think that's the same one that we were looking for. That was the iSense. So it's not the same thing what we're looking at here. PP3 G3 hot PMU VDD main. Getting 3.28 on that specific line, and this is taking quite a while to generate. I don't think this computer can actually handle that. Okay, so this is getting all the way to the SO. Okay, I'm just kind of looking over this real fast. Okay, sorry. I was just kind of studying up on this real quick, because I don't think we're even supposed to get to this point yet. PPVDD CPU awake. I think that's way too far. So somewhere in between, I feel like we're missing a 20 volt line. I don't think this is actually all the information that we need. So I'm just depending way too much on this. For instance, let's check and see PPVDD CPU awake. I feel like we're not at that point yet. Are you getting 20 volts at PP20 volt USB-C XBVBus? Last I checked, I was actually getting 5 volts, so that's why I'm thinking I'm going too deep already into this. I don't think I'm supposed to be at this point yet until I can get 20 volts. So somewhere in between, it looks like 20 volts is supposed to happen somewhere right here, but I'm not getting that yet. Just to, of course, rule out. I doubt this line's going to be present, but let's check and see if PPVDD CPU awake is there. Being that we only have 5 volts, I don't think that's going to be enough for the rest of the computer to turn on. So, if so, this should have some line if it was actually turning on. Well, we're getting 0.75 and pulsing. 0.75 sounds pretty low, but that does sound like that is a CPU line, or a power line at least for turning on. Interesting that it's pulsing though. So we do have a pulse. And see, that was right here at, yeah, PPVDD CPU awake. So let's kind of work our way backwards. Why would it pulse? Last time I had something pulsing like that, it was because of a bad CD3215. That's probably what this is this entire time. And I could have already had one, I could have had both of them replaced by now, instead of just trying to troubleshoot exactly where our issue is. I don't like replacing a CD3215 unless I 100% know it needs to be done. Yeah, 1.8 and pulsing. Let's see if it drops again. Yep, we are getting 1.8 and then drops down to 0. And that was on PP1V8 awake. So the computer is trying to turn on, but it keeps turning itself off. So usually when I've seen that, the last time I've seen that, it was because of a bad CD3215. Oh, that is where the 20 volts starts to initiate on all lines. Never mind. Yep. Okay. So something is causing some pulsing. The computer's trying to turn on, but it doesn't actually turn on all the way. We had a weird CD3215 for a second. What I mean is when we started working on this board, we did get 20 volts at 0 amps for a second. So it did initiate the 20 volts, but then something must have been shorted to where it wasn't actually pulling any amperage. Most of our liquid was around the Thunderbolts, but that might be a red herring here. Let's see what this computer, 5 volts, 0.2, turns off, 0.0. So it is power cycling here at 5 volts. Let's think. Checking the other USB port. Five volts, 0.2, and powers off. 5 volts, 0.2, powers off. Okay, so we have confirmed that the device is still doing what it's doing. Just the weird thing is the fact that it even had a 5 volt line, which eventually turned on to a 20 volt line at 0 amps. Why'd you curse me, Tim? You wanted one of these, and you got one of them. So my mind is still pointing towards a bad CD3215 because we're not getting 20 volts. It's weird though that we're getting a pulsing PP1V2 awake, and CPU awake is also pulsing. But then whenever we checked for P3V3 main P good, it just wasn't there. So maybe somewhere between our CPU awake, let me go back to our start sequence here. Maybe somewhere between our CPU awake, where was it? It was a weird one. Yeah, VDD CPU awake, and our P3V3 main P good, there's something in between that's missing. Okay, there's really not much to work with, or in between, so let's check it out. Let's, I don't know, let's go ahead and check our PMU cold reset L. What is that? Because I'm getting very close to just Russian rouletting replacing a CD3215. Okay, so that's going to come, or go to U4850. We got a capacitor right here that we can test. PMU cold reset L. Let's hook up our power, get a measurement, see what happens. That capacitor right there is supposed to connect to our next line, which was the PMU cold reset L. It looks like it's this top up here. And we're not getting anything. It's just saying it's 0. So L. PMU cold reset L. So when the device is low, it's held in PMU cold reset. If you do, replace the secondary first. When you say secondary, are you referring to U3200 or U3100? U3200 is this one. U3100 is this one. I lost my place. Where was I? Alright, this is a donor board. Just checking to see what that signal is on the donor board. So this is going to be the PM cold reset L. Okay, so it's fine for it to be low on a known good board. Let's keep going. PMU sys alive. Let's check that out. PMU underscore sys alive. System alive. R8003. That's going to be around our ISL. U3200 is the secondary. Okay. Okay, so we are getting 1.7 and drops. So we're still getting some pulsing. Just to make sure, we're going to check that P3v3 P good. And nothing. Okay, so let's keep going. Let's check PMU active ready. PMU underscore active ready. R8063. R8063 is right here. What are we getting? 1.8 and boot looping. Okay. Keep going. So we got PMU VDD main enable. PMU underscore main. Nope. VDD main. There is no enable on this one unless. Calp V power enable coming from U or goes to U7650. Does this one have something like that on the schematic? Let's pull up the schematic, move it over onto this side, kind of cross-reference. U7650 probably isn't the same thing on this unit. No, U7650 actually is also where that P main good signal comes from. PMU active ready was present, then we go to PMU VDD enable, which is V power enable. V power enable, is that a line here? We have an enable here, we have a P good here, but we're looking for V power enable. And I don't think this is going to be on the same, since this is for a different computer. trying to read the schematics of two different computers. Oh, here we are. PMU PVDD. That's the difference, because here it's PMU VDD. So let's check and see if we have PMU PVDD enable. Tiny little resistor behind our T2. Also a tiny little resistor right above our U7650. Let's take a look here. See what's going on. There you are. And what kind of rating are we getting from you? 0. Solid 0. So we are not getting an enable signal for the PMU PVDD enable. Okay. Let's measure to see what the resistance to ground is on that specific line. 46 kiloohms. Compare it to our known good board. Thank goodness we have a known good board. 46 kiloohms. So that's fine. So, in the startup sequence, it says the next step right here after PMU activity ready. Let's see, H9M load secure ROM SMC battery trap. Battery trap. I hope the battery doesn't... No, the battery shouldn't have to be connected anyways. PMU VDD main enable is the next line. Now, let's compare, because this says something about battery. Make sure the battery doesn't have to be present. I'm going to compare this to our known good board. This is why having a known good board or a known good donor board is a good resource. So let's put this back into voltage. And there goes my screwdriver set, so I apologize for all the noise. That looks like a future me problem, because that was about 86 bits that just scattered everywhere. 1, 2, 3, 4, 5, 6 bits just scattered. Of the 6. Okay, found all of them. Okay, back onto this. Let's measure on a good board what the signal is supposed to be with a battery unplugged. 3.2 volts. All right, so to circle back, PMU VDD main enable is the next step in line before we get our P33 Pgood. So now we need to find out where PMU PVDD main enable comes from. Let's look back at our schematic here. Okay, so that's going to come from U7800. U7800 is our power management IC. Okay. So we are not getting a signal from our power management IC to turn this on. In order for us to have outs, we have to have a couple of ins. Power management on, off, low. That could be one. It could also be any of these up here. Our system on chip watchdogs, like the video game, reset. Any of these could also be messed up or holding us in a reset position. So maybe, in this case, the power management IC is not turning on, because we are missing our V-power enable. Okay. Feel like we're getting closer. And I'm sorry for having to keep repeating myself on that. Charger CBC on, and charge initiate low, enable comes out, So let's find out if this is, well, let's check right here the reset that's directly next to it. PCH RTC reset out. Let's find out if that is being held in a low position. That talks the power management IC directly to our CPU, or the platform controller hub real-time clock. There is a test point, fortunately, right here. Switch back over to our microscope camera. And let's see. That test point right there in the center is going to be the test point for PMU PVDD main, nope, sorry, PCH real-time clock reset L. What do we have? 3. So that the PCH clock is not in the reset position. That's good. What about charger initiate? Charger initiate is going to be a line that comes from U7000, sends to our directly to our PMIC. There's not really a clear way of measuring our charger initiate and low, because it directly connects through via underneath the board through some traces to our U7800. Could it be our U7000 is actually being held in the charger initiate low position? Is this preventing the 20 volt from our CD3215s from initiating? Let's see if maybe charger CBC on is something that we can access. That is also coming from our ISL. So H9M load secure ROM H9M is T2, isn't it? It probably is. Especially if it says load secure ROM. That would make sense. If only there was a way that we could somehow measure that specific line. What I'm talking about right now is maybe the charger initiate low and the CBC, charger CBC on. Wouldn't it be horrible if this entire time the T2 chip was in DFU mode? That the T2 chip is just not initializing. H9M load secure ROM SMC battery strap. H9M. Let's see if there's anything in the schematic for H9M. H9M is U3900. U3900 is SMC. So yeah, you're spot on. So yeah, the next step here, before we could actually get PMU PVDD main, is we have to get this to turn on. H9M load secure ROM SMC. Okay. Looks like there's lines going to T2. Okay. It's just strange that it's pulsing though. I wouldn't think that was in DFU mode if it was pulsing like that. Let's see, I didn't type in H9M even. H9. M. So H9M here is the fancy secure T2 chip, and that needs to somehow turn on before we can get PMU VDD main enable. Because that is a signal. No, that still looks like, hold on. Because whenever we did a search in our schematic here for PP, hold on, it was like PPV, PVDD. Too many acronyms. You know, I know where it was. It was right. PMU PVDD. Okay, back onto this. So V power enable is the signal that is coming out of our power management IC. It's possible the power management IC might not be turning on because of the T2 chip. These are all power lines that are coming from the PMIC. We're not getting P33 main P good, which is going to come out of U7650, but that's not present yet until we get PMU P VDD main enable. Joe says it's 2:30 a.m. ish. Oh, yeah, that's right. Where you're at, it's 2:30 a.m. Probably hit to bed. It does not make sense that it is pulsing like that to me either, being in DFU or firmware issues. I'm very confused by that as well. I appreciate you joining me at least tonight. I'm going to try to figure out what is going on here. I'm still confused at the fact that it somehow got to 20 volts that one time, that one singular time. So just for the hell of it, I'm going to remove the heatsink here just to make sure we don't have like a dead CPU or something crazy like that, because I've been down that road before where I troubleshoot a device only to find out that after I removed the heatsink, it was cracked and destroyed. The CPU, that was. So far, so good. Nothing looks damaged, but let's remove the thermal paste just to make sure. I learned quite a bit about T2 now. Thanks. Lots of schematic shifting. Yep, not wrong. I hope it's been informative. I haven't had one that was this difficult, and honestly with the very, very little liquid damage, but I just keep going back to how did it get 20 volts there for a quick second? CPU does not have any obvious signs of cracks. Thank goodness. Well, USB-C systems. Yep. I'm not going to let it beat me, though. Okay. Okay, let's try to continue on. So yeah, what I was trying to figure out is if there's any way to figure out if charger initiate low is present. Where does charger initiate low come from on our schematics? Let's take a look back. That's going to come from U7000, which is our ISL. Being that it's a charging issue, And we got 20 volts one time. Let's see, it looks like there's a via that we might be able to actually etch into and kind of get a measurement for. At least I can get that. Let's see. I already forgot which system it is because my brain is starting to hurt. I can at least get charger CBC on and the charger initiate low. It looks like that there's a via that I might be able to expose using a scalpel and try to get a measurement just to rule that out. Yes, yes. Let's try that next. Alright, let's try that. So this is going to be our CBC line. And then this one right here is going to be our charger initiate. I hope you're pleased with yourself, Tim. You wish this upon me. I had a really easy 820-3435. So you wished upon one of the more difficult repairs. I hope you can sleep at night. Alrighty, so we have exposed some traces. Let's check and see what we get as far sorry, you're fine. Let's check and see what the CBC CBC online is. It's very hard to get. I don't want to slip. And it looks like we also have pulsing. Nope, we just have nothing. And we just have nothing on that, so... Oh, wait, it's trying to. It's like it's trying to get a signal. It's staying at 0. And then it kind of jumped up there to 0.03. Okay, that was on the CBC line. Let's check and see now what we have on the charger initiate line. I don't like the resistors next to it. Really don't like those resistors. And I don't have any probes that are finer tipped than this, so there we are. And we are getting 0.03. So that is low. But if I had to assume, charger initiate low. So the charger is being initialized when it's in the low status, which is kind of what we're getting. It's trying to do something, but it's not actually turning on. And I think at this point, like everything else I've done, we're going to have to compare this to our donor board. So let's go and try to etch into those traces as well. So this is the CBC line again. And that is the initiate low line. Alright, so the device is already at 20 volts. Let's see what it says when it's good. So this is the CBC line. Nothing. Alright, so that's supposed to be nothing. Now let's check the initiate line. .8. So on the initiate line, we're getting 1.8 on a working board. Let me check the CBC line again, because I thought I saw 2 volts there for a second. Nope, nothing. 1.8. So that's different. Alright, so now what I want to do is get a diode mode measurement to see if there's anything wrong with this specific line. So let's check our charging initiator. And we have a reading of 0.6, 0.59. Okay. So going back to our patient board, let's check and see what the diode mode reading is on this one. 0.59. That's fine. I was really hoping for a variance right there. 0.6. Let's check the CBC. 0.59. Oh man, okay. So I was really hoping there we were going to get a different message or a different reading. So on a working board, we are getting, and I'm probably getting ahead of myself here, but we are getting charging initiate low coming from our U7000. On our patient board, we're not getting that at all. Now, I wonder if there's some other steps here involved before we get to that point. For instance, charger, high power, enable low. Could be one. Or charger reset, or charger comp. Any of these. I wonder if any of these are present in order for charger initiate low to actually send a 1.8 signal. Let's see where else on the schematic this is. This goes directly into our U7800 or power management IC, and that's it. That's the only other spot that this is showing. So I wonder if there's a signal. If all of our signals are right, because we do have right here an I2C data and clock line. I wonder what else this talks to. Usually I2C is going to be a CPU line, is it not? It talks to our T2 chip. So the T2 chip does talk directly to U7000. That could be another thing. Charger high powered, enable low. Okay. Let's check and see what we are getting on our donor board and compare that to our patient board, because we're definitely getting a difference right there with the charger initiate low. And that's going to be this test point right here. And 0 volts on charger initiate low. That's probably normal since it's, or I'm sorry, charger high power enable low. Probably normal because when we measure, we have full resistance. Or basically it's going directly to ground, which makes sense because we have a resistor right there. Whew. Okay, you can do this, man. You can beat this board. This is supposed to be low. Yep, same reading as well, so that's perfectly fine. SMC reset N, charger reset N. Let's check out that line, see what that's supposed to be. You can do this. Okay, so that line is 0 volts on a working board. Charger reset N, so that's good. Definitely don't want that shorted. Let's measure on our known good board. Lots of back and forth. Yep, getting nothing on that side, which seems to be fine. Current sensing. Wonder if maybe we have something going on with our current sensing. Let's see, we have let's see what the resistance is between pin 1 and pin 2 on C7023 next to U70 or U7000 or ISL. Let's check that on a known good board. There's a lot of going back and forth between known good board. Alright, so for current sensing, we are getting a reading of about 2.3. Let's check that with our system. Oh, you can't touch the top of that. My bad. 2.3. So our current sensing seems to be the same across both of our boards, so it doesn't look like it's a current sensing issue. So this is getting power in, it's getting the gate. Oh wait, actually this is a different gate. But we're missing the charger initialize L, which is a line that connects to our PMIC. But it comes out of U7000. So there are things that need to be present in order for this to actually turn on. Charger phase 1, charger phase 2. Alright, so let's measure, see what power we're supposed to get on our gate. Let's see if this is our gate. No, it's just for boot 1. No, actually I want to check our gate instead. Charger gate 1. No, let's check boot. I'm sorry. Let's check boot here. So charger boot 1. It's going to be a resistor right here. And then where's boot 2? Right next to it. Let's check and see what our readings are on our board. You can do it. Thank you. Alright, so this is charge boot 1. 10 volts, boot loop. 10 volts, boot loop. Alright, what about here? 10 volts, and boot loop. Okay. Sorry, I didn't have my microscope camera on. Get into that part in the evening where I'm just forgetting to do things like that. We're going all the way up to 18 volts and counting. Getting about 18 volts here as well. Okay, let's see if we ever had 10 volts when it first turned on though. Okay. So it's at 10 volts when it's first turning on. Then when it actually gets 20 volts, it starts to crank up to 18 volts, which is the boot sequence. Okay. So we're still pulsing, which is making this really difficult. Okay. So now we need to make some decisions because we've spent a lot of time on this board. This live stream has been going for 3 hours and 40 minutes, and I feel that when we did the other board repair, that was probably about a 20-minute repair. So this has been about a 3-hour MacBook Air board repair. We got a weird charging when it first turned on. And we got 20 volts there for a quick second with 0 amps. So being that it's kind of power cycling, and from my experience, I've had power cycling happening from bad CD3215s. I'm going to replace them because at this point, it seems like if it's not a CD3215 and it's not a U7000, that's causing the pulsing. See, I'm still thinking U7000 because we're missing that initialized charger L, but there could be all sorts of other things that cause that issue. Being that the computer is not turning on, if it's not a CD3215 or a U7000, it's very possible then it's going to be something with the T2 chip or power management IC. I'm thinking more of a T2 chip. The Thunderbolt ROM what kind of trolled us because there was a little bit of liquid there, but all that seems to be working like it should. So let's change U3200. And if that doesn't work, let's try U7000. Worst case, that doesn't work, we can try U3100. And if neither of those work, I'm just going to have to call it quits on it for this one, because it could be something around the T2 chip that is just a little bit past my expertise. Let's do it. Let's get to it. I wonder if a bad CD3215 would also cause that U7000 charging initiate. You know what? Let's replace U7000 first. And then let's replace CD3200. Let's do that. How about that? So this is going to be the dreaded ISL 9240. I gotta make sure that I have one. I know I have one on my donor board, but I'm pretty sure I placed it recently. I don't think I put them in stock yet. I have 2 of them. So if they don't work, I'm gonna make sure to put them back. My iPhone just sent me a notification, said sleep well. I'll sleep well soon enough. Now we don't want to destroy this ISL because it may be fine, and if so, we'll gladly put it back. So when we checked for the charger initiate low, on our known good, we were getting, pay $50 for mine. Yeah, that sounds about right. I think that's about how much I paid too. What I was going to say is, on our known good board, when I checked our charger initiate low, we were getting 1.8 volts. On this board, we're getting 1.7. Now, I'm curious if that's because the data lines that come from the T2 chip aren't properly communicating to U7000 because our 20 volts isn't present. Or could it be that our 20 volts won't be present until we have charger initiate low? Because if charger initiate low is present, I'm thinking it will then turn on the power management IC, the that enable signal. I already forgot which one it is. Let me see if I can multitask real quick. That enable signal that we were looking for is PMU VDD main enable. I'm curious if that's not turning on because we're not getting this initial signal turned on. That's kind of my thought process for this. But yeah, ISL 9240s are still very, very high. Because here's the thing, whenever we measured in diode mode to see if there was a difference, everything was fine, which tells me that something is preventing the U7000 from sending that signal, the signal that it sends out to generate that 1.8 volts. So I hope we're on the right path here. Okay, we gotta clean this area up. Alright, all of our pads are nicely wicked up. And they're ready to have a new ISL 9240 put in its place. So to add a little bit more flux and just kind of melt it down and make it a little tacky. And let's go grab an 9240. And let's see if this one is already pre-balled. It is. Gotta make sure that we put it back in the right orientation. And then just so it doesn't blow away from us, I'm going to turn down our throughput. Definitely don't want this chip blowing away. Add a little bit more flux and watch it dance into place. Okay, looks like it just wiggled a little bit. So we're almost done soldering it down. Kind of poke it. Okay. Ooh. Let's let that cool off for a second, actually. It's a little too hot to the touch. I'm just checking out my balls on the ISL. The ISL's rework balls. Solder balls. Something doesn't look right. It doesn't look like it was put on at an angle. I don't feel good about that. It almost looks like whoever had pre-balled this. Looks like they had maybe a little bit more solder paste on this side of it than on the right side. Let's make sure that nothing is bridged. And how we're going to do that is we're going to put this back into diode mode, because I remember that my diode reading was about 0.59, and if it's anything else than that, then I'm going to actually have to pull this up and reball it myself. Alright, we got about 0.59 on that side, 0.59 on this side. So I think just whoever reballed this, because this was reballed by hand, this didn't come from a factory, looks like someone had actually pulled this off of a dead MacBook logic board. They added a little bit more solder paste onto the left side than they did the right, but it does appear to be actually on there like it should. Let's see if this is going to have any difference, any change. Five volts, 0.0 amps. So, big difference we have here is now we have no amperage consumption at all. Which leads me to believe that those balls on that ISL was not properly put on. 5 volts on this side at 0 amps. So yeah, that ISL was not actually balled properly. And that's just something we now have to deal with this industry, since we are unable to get new ISLs, specifically the 9240 from Intercell. So this is just one of the pains we have to tolerate to get a working board. But that's not a problem. We can fix that. We're just gonna have to reball it ourselves. It's a pain, but it's our pain. It's a struggle, but it's our struggle. Okay. Now, while this is still warm, I want to go ahead and wick up this area. Okay, so here is our ISL. We're going to have to remove the balls that are already on here, but we don't want to wick this up. So instead, what we can do is just briefly touch this up, briefly touch this up with our micro pencil. That's not what happened here. Let's try that again. Now that we have that touched up, it is time to clean this up and get a stencil. We're going to use an iPhone stencil more than likely. Okay. Let's get our reball kit out and reball this properly. Oh, looks like I actually have specifically a stencil for this. Perfect. Okay. Okay, so we get some new balls on there. Cool. So we got all the new balls on our ISL. Let's wait for that to cool down. And then we're going to put that back on. And let's go ahead and prep our area again. You can tell I'm getting tired since I'm not talking as much. Okay. Okay, looks like it's actually going on straight this time. It was kind of lopsided when I put it on. Okay. And we got the ISL on there again. So let's let this cool off one more time. And kind of take a look back at thinking process as to why I replaced the ISL. So we were measuring on charger initiate low 1.8 volts on a known good board. Now that line goes directly to our power management IC. So when we check the schematic, that line is an output line. So charger initiate low has to actually send a signal from U7000 to the power management IC, not the other way around. So if this fixes it, I'll be so happy. If it doesn't, it tells me something over here, such as a I2C line, which talks to our T2 chip, could still be preventing it from sending the signal. That's my thought process. That's exactly why we went ahead and replaced our U7000, our ISL, the ISL 9240HI, just because we were missing that one specific line. Now, the board has had time to cool down. Let's find out if this fixed it. If not, and we're still getting about 0.2 and rebooting, this ISL, the original one, is fine, and we can put that back in inventory. Let's see what happens. 5 volts, 0.2, 0.0, 0.2, 0.0. So, we've rolled out the ISL. We're getting the same voltage as we had before, which means their ISL is perfectly fine. We can put it back in inventory because these are really expensive ICs now. They're not like what they used to be. It looks like that charger initiate line will not turn on until some communication between the clock, it looks like. You know, we actually have another sensor. I didn't check right here actually. Right here. I didn't check to see this current sensing line right here. Current sensing on ONOP. Or I guess this be positive, negative. We could check that real quick to see if this is a current sensing issue. Okay. 1 second. Let me put away this ISL because it's good and there's no sense in getting rid of it. We made sure not to damage it. So what happened though, why I had to reball it is from where we had got it from, these are reballed chips because you can't buy them new anymore. And that's because Apple has an agreement with Intercell to not sell this specific chip to anyone else but Apple. So whoever had reballed it did not reball it properly, and it was not put on properly. So now we had to reball it ourselves. But we did find out that we're still experiencing the same issue. No sense in getting rid of our 9240, still, or ISL 9240, it's still a good chip. Put it in a nice safe place, right next to my social security card, since it's just that important to me. Okay. Current sensing. Let's check current sensing in, current sensing out. I think that's what that stands for. And what we want to check is basically what the resistance is between C7020, C7020. Something is going on here that is preventing this one signal from being made. And like I said, for all I know, this signal might not be read until the computer actually starts pulling 20 volts. It's a possibility. So right now, I have a resistance of 0. Nope, took a second. It says 0 at first, and then it starts climbing indefinitely. Let me check with the known good board. Same thing. I'm probably not measuring the right thing. So what we want to check is the difference between, because we have a shunt resistor here, here and here. So that should be 1 ohm. Through here is negligible. And then right here we have another one. So this should be 2 point something on both of these lines. I'm not measuring the right thing, that's why. Okay. That's exactly why. I'm not measuring the right thing. Man, it's getting late. This is what we want to measure. .5. That's on the known good board. Let's check on the patient board. .5. Okay, current sensing isn't the issue. PPBus G3 hot runs through here to turn on PBus gate Q4. We have a couple different gates right here between Q70 and Q7040 and Q7030. Okay. Let's make sure this is getting all the right power. PPDC in goes in through here to turn on this gate. Boot, we've made sure that was okay. Oh, I'm really reaching here now. .7 and rebooting 10.5 and rebooting. What was that other gate? 10.5 rebooting, 5.7 rebooting. Okay, and that's on the patient board. Man, the bathtub computer I did a couple of months ago wasn't this. It was complicated, but it wasn't really on this level of complicated. We're getting 15 here, going up to 18. You got 13 on that side. Let's unplug it. Plug it back in. 5.8, which is what we had before the device turned on. And this one was like 10. Yep, 10.5. And then after it turns on, it starts going up. So the known good board is still reading about the same on the ISO as the before it actually starts taking a charge. So what else could we potentially be missing? Gate 1, all this here, charger gate 2. Let's check that out. Charger gate 2. Oh man. Go back to the original board, patient board. So this is charging gate 2. It's just staying at a solid, oh, it tries to go up to 5 and then it stops. Yeah, 4.5 and then immediately stops. What about charging gate 3? It's kind of hard to reach. Goes up to about 4 and then immediately turns off. And this one's just staying at a solid 0. And this one is staying at 0.3. That's with it being turned on. This is the known good board. Let's go back. Staying at 0. Went to 1, 2.4, turning off. And still kind of staying low. Okay. So Q3 and Q2 are low. And when they are low, it's allowing power to go, let's see, because they are N-channel MOSFETs. And then this actually starts sending power. But instead, in our case, they're staying high. They're staying at about, I couldn't even remember anymore. Brain hurts. 7 point, or Q7030, these were definitely high, so this wasn't actually turning on all the way. They were actually pulsing. And let's see why. That is a signal that goes to gate Q2 and gate Q3. I'm surprised my microphone's still working after all these hours. Oh man, it's almost 3 o'clock, and I still have other boards to work on. This is one that I'm probably gonna have to call it quits on. Like I said, I was still thinking about replacing that CD3215 since we did get a weird reading. And this is reversed. See what we're getting. So we actually go up to about 1 volt and then drops. Goes all the way up to 5 volts. What about on this one? 0, 5 volts, and then drops. Okay, so the strange thing is with the good one, it's never getting that high. It's never going to 5 volts. So, what? 0.3 and then goes to 0.8, but it never goes, well, it goes to 2.4. We got 0, 0.3, 0.8, 1, 2, and then drops. But it's never going to 5 volts like we have on the other one. Okay. So the highest on a known good board is going to about 2.5 volts. On our patient board, it's going all the way to 5 volts and then shutting off. So, why is that? Is that almost like is that almost the equivalent of an inrush limiter? Where does the signal come from? Signal comes from ISL, which we've already addressed. So Q7040 is a MOSFET. Same thing here, U7040. and this is Q7030. Okay, so these are critical, and so these are N-channel MOSFETs. Okay. Because this is almost the equivalent of an inrush limiter. Is it possible that Q7030 and Q7040 is acting as an inrush limiter and shutting itself off because it's getting itself too high? Charger boot, but then we also have signal here, charger boot 1, RC charger boot 2. It would be weird that they're both acting that way though. And they're not tied to each other, other than they go to U7000. That's what I'm curious. Because when we take a step back, for some reason our PPDCN was reading 12 volts. I'm at a loss for words on this one. My head hurts. Okay, let's keep trying to figure something out. Whew, okay. Doing a little bit more studying here. Now that we replaced our ISL, let's make sure that we're still getting a proper reading for PPDC and G3 hot. Let's start there. Thanks, Tim. I appreciate you still hanging out. I think it's just you and me right now. Alright, so for PPDC in, we are still getting 5 volts. That's good. And let's check and see what PPBus is. .3. Okay. So, here's the confusing thing. If we were having something not working properly with our U7000 to generate that 1.8 volt on charger initiate low, I would imagine we'd also not have PPDC and G3 hot or PPBus, but those are present. So something else would have to be missing. What about charger comp? I feel like we already looked at this, but my brain hurts. Charger comp is a 1.5 volt line. And when we compare that to a known good board, 1.5. I think I'm spending too much time around the U7000. Okay, and we checked this enable line was there. 7080 is supposed to be 1.8 sleeper S2R. .8 turns off. Nope. Yep, 1.8 and then turns off. So that's there. So it takes us kind of back to charger reset N was 0, which is normal, and then we have our I2C lines, which is going to be part. If we trace back up, it's going to talk to a resistor here. Let's see if the clock and data lines are kind of the same. 1.8, 1.8, and boot looping. I feel like that's normal. 1.8. 1.8. So the clock and data line, at least, are the same voltage. So everything that could go into the ISL that should be working appears to be working. Test point charger SMC reset low. Looks like that doesn't work, and that doesn't exist. No! Flex port view has stopped working. Okay, let's give this a refresh real quick. Oh, man. Alright, let's pull this back open. It's a not connected line anyways, so that's perfectly fine. Okay, so from everything I'm seeing here, that 1.8 volt line that we're probably still missing, but I'll double check, might not be generated until something comes from the PMIC that asks for it to start pulling. Let's try, see what happens when we get this reading here. Yep, nothing, just not getting 1.8 volts. So I'm curious to know if this initialize low, which talks directly to U7780, 7800, could be caused by something else. Still very strange that the computer even turned on or had 20 volts but 0 amps in the first place. I'm going to say at this point it's time to replace U3200. I'm just kind of inspecting the area some more. Alright, let's just jump straight into it and replace U3200. Before that, let's see what our diode mode measurement is on that P-good signal. So we hit about 0.57. OL. .58, close enough to what we had. Yeah, 0.58. Just reaching, that's all. 0.57. Okay. Back onto replacing this. Whew. All right. So, Still very strange that for a split second this computer pulled 20 volts at 0 amps. Makes me think maybe the CD3215 could still potentially be bad. I almost had to go back and watch the stream to see which CD3215 I turned on first. Oh geez, 4 hours and 40 minutes? Where did the last hour go? Was it just taking care of that U7000? Ooh! I think we pulled something up. Almost. Almost pulled something up. Let's turn down our temperature. Not our temperature, let's turn down our throughput. Oh no, oh no. Okay. Definitely getting tired, man. Let's fix this. Just a little mishap, but we can fix that. Okay. Let's get some wick. I did a 3-hour video repairing an A1465 the other day. Granted, it wasn't late, but I feel your pain. Thanks. Yeah, I'm just tired. Because I've been here... I actually had to go to an oral surgeon this morning for a consultation. But, I've been here since about 10:30 a.m. Alright, I'm going to hold on to that just in case this doesn't fix the issue. Alrighty, Now let's get CD3215. Alright, that looks pretty lined up. Let's go ahead and put it down. Turn our throughput so it doesn't blow all over the place. Alright, start increasing the throughput. Alright. So now let's let this cool down for a bit and see if we changed anything at all. Just letting that cool off in our fume extractor for a minute. Ooh. Okay, let's add some time to chill. You moved the diode above CD3215. I mean, it moved around, but it should still be in place. Let me double check real quick, since you mentioned it. Yeah. Yeah, it just kind of moved around, but it didn't actually, like, pop off. It was just dancing was all. May want to reflow that guy flat. Let's see what happens first. If it doesn't do anything, then I'll reflow flat. Whoops. Wrong camera. Okay. We have 5 volts, 0.2, 0.11, 0.2, and 0. So we have the exact same reading as we did before, which means that CD3215 was probably fine. Reading 0.2, turns on, turns off. The board's still hot. I have a couple of these. Let's just go ahead and throw another one on there. let's replace this one. I'm still just confused how we got 20 volts there for a second when we first turned on the computer. That I'm really confused about. So we looked at our Thunderbolt. The Thunderbolt looked like it was reading like it should. The clock seemed like it was reading. It was getting the proper power. Then we started looking around our U7000, and we were having a weird reading, specifically on the charger initialized low, because we were getting 1.8 on our working board, but on this one we were getting 0. And the other connection it has is to the PMIC. Now when we follow the startup list, everything seems to be good, except for when we get to, I think it was PMU PVDD main enable, which is a line that comes from, it looked like our T2 chip. So if this doesn't work, just thinking about it, and this would be so stupid, but I could definitely see this potentially being an issue. What if this computer was actually going into a T2 state? Or a DFU state? But it can't do DFU mode because there's not a battery connected. Is that a possibility, that the T2 chip, if it's going into DFU mode, needs the battery to be present? I'm going to try that next. Put it back in the housing with the battery connected, and see what kind of reading we get. We have one tiny little component that tried to lift up. So what we're going to do is lower our throughput, lower our temperature, and just kind of push it back into its home. As Bob Ross said, we don't make mistakes, we make happy accidents. So that went back into its home just fine. So now let's go ahead and put just a little bit more flux right here with our CD3215. And heat it up some just to make it a little tacky. And we're going to grab another CD3215 that we have here. Alright, so just like before, we're going to use low throughput, high temperature. And gotta watch it dance into place. Alright. So we got that CD3215 on. All of our components look alright. And, like before, let's let it cool off. Okay, I think that's had plenty of time to chill out. And let's see, both CD3215s replaced. U7000 ISL completely replaced. Let's see what kind of reading we get now. Five volts, 0.20. Okay. So we're still getting the exact same reading we had before. So this is the part that I hate about the T2 chip, is it has its own firmware built into the T2 itself. And I might be very wrong when I say this, but I think it actually runs watchOS. Probably very wrong there. But being that it's doing the exact same thing, with everything that we've done to it, I am now curious to know if it's going into DFU mode, but it keeps rebooting itself because it doesn't have a battery connected to it. The computer will turn on fine, but without a battery, but I don't know if it'll boot into DFU mode fine without a battery. I'm going to reconnect it to its battery and see what happens. Its battery did have a good bit of damage on it too. Let me clean up some of the flux first before I put the board down. Because I don't think the power management IC is the issue here. I wouldn't blame that. But staying at 5 volts and power cycling makes me think T2. Which would be unfortunate because the main reason we're fixing this board is for data recovery. And if it turns out it's in DFU mode, we probably aren't going to be able to salvage the data if we have to restore the T2 firmware. Which means this would be a fun learning experience. One I didn't really want to do. One I didn't really want to sign up for at this point. But I won't get too ahead of myself here. I'm not even going to worry about the heatsink yet. I just want to see what it does now with the battery connected. So 5 volts, 0.2, 0. So it's doing the exact same thing. And still power cycling. So I'm not thinking T2. Well, I'm sorry. I'm not thinking DFU mode. Unless this battery is just absolute garbage and it's trying to boot into DFU, but it can't. Yeah, still doing the exact same thing. 0.2 and then goes to 0.9. Or 0.2 and then goes to 0.09. Basically nothing. And then goes to 0. Oh, you gotta be shitting me. Hold on. We got 20 volts now. 20 volts, 0 amps after I connected the battery up all the way. This is new. Hold on. Is it in DFU mode? CPU, it does not feel like it's getting warm at all. 1 second while I get another computer that has Thunderbolt. Because we've just replicated our same issue where it got 20 volts at 0 amps. This is the second time we've got it to happen, which leads me to believe this may have been a T2 issue. Firmware at least. So what we have to do in this situation is get a MacBook that has USB-C and hook it up using Apple Configurator. So we're going to connect USB to USB. This is an A1706, A1708, I mean, this is A1708. And let's open up Apple Configurator 2. 20 volts, 0 amps. With Apple Configurator 2 opened, I don't have anything just yet. Just feeling around for anything remotely warm, because I don't want to unplug this while it's at 20 volts. Because I'm afraid if I disconnect it, it's probably just going to do exactly the same thing again. So while it's on, just wanted to measure for any power rails. We have 11 volts on the SSD power rail. Okay, let's see what other power rails are here. Just while I have it on. Alright, PPBus. What is PPBus right now? PPBus is 11. Something is pulling PPBus down. Okay. Let's examine underneath the thermal imager if it will actually decide to open up this time. This is going to kill my frame rate for a minute here. But something is definitely pulling PPBus down now. We have 20 volts coming from the charger. trying to see it. Just waiting for it to actually load because our frame rate's stuck right now whenever we try to do this. I just really don't want to let go of the power, being that it's at 20 volts right now. Waiting for it to update. Come on. This computer really struggles, but it can do it. Come on. Do the thing. Alright. Oh my god, it's like updating. Okay. Alright, I'm gonna give that another 30 seconds, and if it doesn't update, then we're just gonna unplug it and look at the other port, the master port. Yeah, I think that just got messed up. So let's see if we can close out of the application and reopen it. Okay, so let's reopen it back up. Alright, so main thing we can see getting hot here is going to be the C3215, or I'm sorry, the C2 chip. It's at 38 degrees, which seems normal. That seems like it's trying to boot up, which also makes me think that it's in DFU mode. Okay. That's what I'm thinking here. Either that or there's still a missing power rail. CD32, I'm sorry, PPBus, I'm just saying CD3215 every time now. PPBus for some reason is reading as an 11 volt rail. That seems a little odd in my opinion. Let's switch the camera over just so we can see what's going on here. Okay, yeah, this should be the data pin, or the data connection right here. But when I go to Apple Configurator, nothing is popping up on that end, so it looks like that it is not going into DFU mode. Being that PPBus is only reading 12, or I think it said 11 volts was a little odd. Let's measure one more time. So this is PPBus right here. We're getting 10.9. or 11 volts, which is strange because that's the same measurement we're getting about right here on our SSD although I think that is PPBus as well. I'll just double check real quick. So right here, yeah, PPBus SSD, so that's perfectly fine. But still weird that it's pulling that low, which this is where our liquid damage was in the first place. So, because PPBus is supposed to be about, I think, a 12.3 volt line. Is it possible that U9060, which is where some of our liquid damage is actually turning on now and is preventing our computer from booting up? Is there any other, let's see, 2.7 phase, let's take a look at that. Completely dead, or just no power at all. We got 10 volts on this side, because this is a coil. On this, hold on, no, coil's over here, my bad. Looking at the wrong thing. Okay, so our coil is right here, and we have nothing on the coil at all. Nothing at all. Let's check and see if that PMU signal is present. So what was this? PMU, PVDD main. Can we see it on this side of the computer? One tiny little components right here. It's gonna be a little tricky. But let me see if I can get that, because before we had absolutely nothing. Let's see if that's still here now. We have 20 volts. Why do we have 20 volts? I'm not too sure. I really wish I had an answer for that one. When we put it under the thermal imager, we can see that the T2 processor is trying to turn on. And when we measure, we're still missing that PMU signal. Sorry, I meant to switch over to microscope camera, but really bad at doing that. So that is the signal that comes directly from the PMIC. What other signal did we have? Like 1. V8. Let's check, for instance, if that is staying solid now, because it was pulsing. It's in a spot I can't easily get to. Yeah, it's in a big spot I easily can't get to, or can't easily get to. But maybe over here. Let's check and see if anything else is pulsing. .8 and still pulsing. So even with getting 20 volts now, the device is still pulsing. Okay. Just gonna go ahead and unplug and see if we get that 20 volts again. I'm gonna plug it into a different USB port. 20 volts. So, something's going on here, that when it's connected to a battery, it gets 20 volts. Just once again, makes me think DFU. But whenever I go to Apple Configurator on our other computer, we're not getting anything. So it doesn't look like it's going into DFU. Let's see if we're getting 20 volts consistently now. Yeah, 20 volts, 0 amps. So we definitely have a change here that I've never seen. And at first, when we started working on everything, we went ahead and we hooked up our USB charger, the MagSafe, or not MagSafe, the Thunderbolt 3, into the computer, and it for 1 second actually took 20 volts with 0 amps. So I'm kind of at a loss here because we've tried so many different things to replicate that without a charger, or without a battery. But it gets 20 volts and 0 amps when connected to a battery. This is a weird one. I've never seen this one before. So let me see now if we get any. This is just a matter of trying to find a pattern. I'm going to unplug the battery this time. Alright, so battery's disconnected. Five volts, 0.2, 0. 5 volts, 0.2, 0. So that is consistent. That is staying the same no matter what we do to the board. Connect the battery, which leads me to believe T2. Let's see if we get 20 volts again. 20 volts, 0 amps. I gotta find out if I have one of these batteries in the back. It is 340. Oh my god. I do have one of these batteries. Okay, let me grab one off the shelf and try to get some other measurements now with the battery. With battery connected, we get 20 volts, 0 amps. Without battery, we get 5 volts, 0.2 amps. I'm still thinking this is something going on around U7000. So is it possible, now that we're getting 20 volts, that these gates up here, which I thought was the equivalent of an inrush limiter, are acting like they should? Let's take a look at that. Let me take a look at that here. Okay, so we confirmed with the known good board that when the computer started pulling 20 volts, this was locked to 0. And that is what we're getting. That's being pulled down. Same thing here, staying at 0. Alright, what are we getting now over here? 0. Now that's not normal. And then what about here? 0. That's not normal. So when we have one open on Q7040, that's right here. Gate Q4. And PPBus is directly connected to it. And PPBus is being pulled down currently. Okay. Okay, so what I'm going to try is see what these gates right here are reading, and whenever they're connected to a battery, because I haven't done that yet. So I'm going to get a new battery. Okay, let's see what voltage we're getting here. Yeah, 18. 19. .7 0. Okay. So something looks off for sure around these specific MOSFETs. The Q70 30 and Q70 40. Because whenever we hook it up to our computer, or our power supply, PPDC in, which is supposed to be a 20-volt line, it's going to be 20 volts on this side. I have half the mind to just swap these at this point and just see what happens. Because we've done just about everything else here in this area. Unless this just isn't acting like it should, because PPDC in... Let me see if it's actually 20. It should be 20 because we're getting 20 volts. Maybe because PPBus is being pulled down? Alrighty. Okay, back to this computer. So I'm curious if that's what the issue here is that we have some sort of issue with these two MOSFETs. Oh no, I can tell people from another time zone are starting to join the live stream. Usually between like 1 to 3 o'clock, there aren't anyone else joining. So I've been doing this live stream way too long. Alright. Just because they may potentially have a bad battery, let's pull the logic board out, hook it up to our known good battery, just like we did a second ago where we were getting those 18 volts readings. Alright, so we got our board connected to the battery. Whenever we plug our charger in, we should get 20 volts now. What? What? How are we getting 20 and then 0.2 and 0, which is exactly what we were getting before. Yeah, there we go again. 20 volts. Inconsistent. 20 volts at 0 amps. The only thing we saw whenever we turned on the thermal imager that was getting a little bit warm was the T2 chip. Okay, let's look back at these MOSFETs here, because when we checked our PPBus now for some reason is being pulled down. It's 11.8, so it's not staying the same. Last time when we checked, it was actually just right at 11. Now, PPBus on this model is usually around like 12.3, but we're just getting 11.8. What was it? 11.8? Yeah, 11.8. So something weird, for sure. Something's pulling down our PPBus a little bit, so potential short. Okay, back onto these MOSFETs. That I'm assuming is the equivalent of an inrush limiter on an older MacBook. So, on our good board, this should be somewhere about 18. And we're not getting anything there. We're getting 004. Right here, same thing. Alright, here we had about 1.5, we're still getting 0. And right here, still staying at 0. So, what I'm assuming is going on here is that these actually aren't turning on. Let's gate 2. These actually aren't turning on because we're not getting the right power through. Let's see, PBDCN G3 charger, AMON. What voltage do we have on that now? Let's see, that's flipped over. Okay, so around here, which is directly connected to that MOSFET, what do we get? We're just getting 0. Because that should be a 20 volt line, but we're not getting that at all. What about PPDCN G3 Hunt? What are you? So you should be about 20 volts. Since that's exactly what our charger says it's putting out, but what are we actually getting? Look at that. PPDCN G3 hot is not present. Now, is that because we have the battery connected? That we're relying more on this side, PPDCN G3 hot and PPVBat G3 connection, because we're getting 20 volts now that the battery's connected. What? Q7065. Does that have anything to do with anything? Q7065 looks perfectly fine. Is that on the other side? It is. Don't really have access to that easily right now, so let's check pin 5. Pin 5 is going to be all the way on the far back. And connected to all these other tiny little components. Getting 11.8. And charging. Which is exactly, I think, what our PPBus had. It was 11.8. Yeah, 11.8. So PPBus is getting the exact same power as our excuse me, as our PPVBat G3 connection. Okay. So then what's going on with PPDC and G3 hot? This is on the bottom of the board, which I don't really have easily access to, not without flipping. But I do have access to Q70. So let's check pin 1, which is going to be save bat G, which eventually makes its way to PPDC and G3 hot. Oh man, I'm starting to get hungry again. Okay. Nothing. Okay. How can PPDC and G3 hot be missing, but the computers still get 20 volts? What is going on here? Okay, time to flip the board over. Alright, I'm not really able to reach that PP, or that, not the PPBus, but the PPDCN G3 hot. I'm sleepy. Okay, let's see what PPBus or PPDCN G3 hot is on this side. Still 0. Okay, so I'm starting to learn something. How is it that PPDCN G3 hot is not present? Okay, so this is the top of the circuit, it says, from USB-C source, PPDCN G3 hot. And it's supposed to make its way through U70,000. So the first point of entry is going to be around R7020, the shunt resistor, right above U7080, which we've already looked at before, and there's no power. So what is going on? Kind of the same thing here. PPDCN G3 hot charger aim on is not present. PPBus. And this is coming from the battery. Okay, let's measure R7015. I'm pretty sure it's still going to be 0. I'm just making sure there's like no dead traces. Let's see if that 1.8 line is present. It's not. Still missing. Okay. No, I've made a discovery. I don't know if it's a discovery that I just want to stop on, but it's definitely an interesting discovery, and I just can't think right now. But essentially, we're getting 20 volts now. Only when the battery is connected. So, from my experience, that usually means something over here, like Q7065, is bad. Let's see if charger VBAT is open. .8 on charger VBAT. And giant fuse all the way over here. Has nothing on that side. What? So we have a little fuse right here. And this fuse is F7000. F7000 is going to connect our PPBat G3 connection and our PPVBat G3 fuse. If we touch pin 2, that is supposed to be the PPVBat G3 connection, which we're getting 11.8, which is power that is coming from the battery. When we check the other side, get nothing. Nothing at all. Okay, so now what I'm going to do is unplug all power, both battery and the charger, and just check and see if this fuse works. Okay. How? How do we have a blown fuse? But no, we don't. We don't, because right now we're measuring right now in resistance, and we have 0 resistance, which means it's not shorted. What? Let's measure our resistance. Here is OL. And it should stay OL. And this is a coil. What? Or not a coil, this is a wire. How is it that one side of the fuse had no power, but the other side was fine, but the fuse is fine? What? What? I am genuinely confused. That doesn't make any sense. Is that a partial fuse? Alright, so battery connected. 5. And we're back to getting only 5 volts. Maybe the battery's not connected all the way. Oh, yeah, it's not. Hold on. Okay. Battery's in pretty solid now. So, when we plug in our charger, we get nothing because our charger fell off. Man, this is going to be one hell of a video to edit. This is a 5-hour and 40-minute video. Okay. So, 20 volts. Okay. Switch it over to voltage, and we probe this pin. This pin gets 11.8, which should be power coming from the battery. Check this side. Oh, come on. I checked a second ago. That said 0. That said 0 a second ago. Okay. So back on what I was trying to figure out is if Q7065 is working. So on pin 1 of our F7000, we get 11.8 volts. So 11.8 volts on pin 1 of F7000. Okay, well, what do we get on gate, which is going to be pin 4. Let's see if there's a couple components around that we can kind of probe. That's going to be charger B gate. We accidentally chose V gate. We want B gate. And there's a test point right next to our U7000. I can kind of see it here with the naked eye. So I'm just going to kind of probe that real quick. 4. Okay. So that is being pulled down, which is normal if it's going to be charging. And then that should mean that PPBus G3 charger R should be present. Another tiny little component we can see with the naked eye. Yeah, 11.8. So that circuit is working like it should. Right here. And this is the charging current sensor, which eventually makes its way to PPBus, which is 11.8, because this battery, for some reason, is reading 11.8. The part that I'm confused about is I thought PPDC and G3 hot would still be present. But whenever we measure for it, it's not. Actually, I can't do that with the naked eye. I'm going to have to do that underneath the microscope. I'm sorry. Yeah, so PPDC and G3 hot is 0. But somehow we're getting 20 volts. It's just kind of turned off. I'm officially lost. I am officially lost. Okay. Yeah, getting 20 volts there. That's normal. I don't know. I genuinely do not know anymore why we're getting 19 volts and 0 amps when the battery's plugged in. I'm gonna stop here. The first 20-minute video was fun. I'm gonna make sure to download that and turn that into a quick edit. But the additional 5.5 hour video here has not been my proudest moment. I'm mentally beat. So I'm going to go ahead and call it a night because where I'm at, it is 4 o'clock in the morning, and I have plenty of repairs that need to get done, but this repair is kind of just throwing me a little bit behind. Normally in a case like this, we would deem this one irreparable, but I've just spent so much time on it, I don't want this one to best me. So, anyways, I'm going to go ahead and end it here for the evening. So I greatly appreciate you all joining me. And I hope you all enjoy the rest of your, well, in my case, it's night. Some of you may be morning. Thank you. Have a great one.